Hello and welcome to my science tutorials. In today's video, we want to look at coordinate geometry, where we'll be looking at how to calculate the gradient of a line. Alright, so without further ado, let's begin. Now, how do we calculate the gradient of a line? Now, before we look at how to calculate the gradient of a line, let's look at what a line is and what are the important parameters that we can get from a line. So let's draw our Cartesian plane. So we have an axis coming from top to bottom here, and then another axis horizontal like this. Okay, now this is our Cartesian plane, and then the horizontal axis over here is what we call the x-axis, and then the vertical one over here is what we call the y-axis. Now supposing we have a line over here, so let me use another color to draw that. So supposing we have 2 points over here, so a point A and then another point B. So these 2 points are our points forming our straight line. So this is the second point. So if I draw a straight line through these 2 points, we are going to have point A over here, which has the coordinates x1, y1, and then we have point B, which has, this is B, which has x2, y2 as its coordinates. Now if we try to complete this straight line that we have by making it in a form of a triangle, so we extend this guy down a little, and then we extend the horizontal line as well. So I have my horizontal axis here, so I extend this guy as well to meet over here. Now if we do that extension, this slope or the slant of the line gives it or makes it has a slope. You can see it's slanted and it has a slope. The slope is what we are calling the gradient. The slope is the same as the gradient. Now if you look at the vertical component over here, which is from top to down, we can see that this is on the y-axis, and for you to find the distance from here to here, that will be y2 minus y1. Now for you to find the horizontal component over here, this is on the x-axis because it's horizontal, so that one will be x2 minus x1. Now if we find the ratio of the change in the vertical axis to the change in the horizontal axis, that gives us our slope or our gradient. So our gradient, which we denote by m, is equal to the change in the y-axis, so we have y2 minus y1 on x2 minus x1. So this becomes the equation for finding the slope or the gradient of a line. Now note very well that your initial point, or the point given to you first, which is A in this case, will have your coordinate x1, y1, and then your second point will have your coordinate x2 and y2. Do not interchange them. Now assuming the same scale is used on both axes, let's say 2 centimeters to 2 units on the x-axis, and then we have 2 centimeters to 2 units on the y-axis as well. So we have here 2 centimeters to 2 units. If we use the same scale on both axes, then we can also calculate our gradient m to be equal to tan theta, where theta is the angle formed over here. So this angle over here is theta. So if we know the angle, we can find our gradient just by applying tan of the angle theta over here. Okay, so we know that tan is, the abbreviation is TOA, so it's opposite over adjacent. And if you look at this angle, this is the opposite, which is y2 minus y1 on adjacent is x2 minus x1. So it means tan, okay, so let me cancel this, tan is equal to this, okay, so which is what we are saying, this is also equal to the gradient. So it means that if we want to find a gradient, m is equal to tan theta. All right, now let's have a look at some lines and let's try to determine whether the gradient to be positive, the gradient to be negative, whether the gradient to be zero, or whether we'll have a finite or an infinite gradient. So let's have a look at an example. So let me draw my axis. So I have my vertical axis here, and then I have my horizontal axis. Okay, so this is my y-axis, this is my x-axis. Now I know my line is not straight, kindly just bear with me. Now say I have the line, one of the lines over here slanting upwards like this. I have another line coming down like this. So let's say from here down here. Then I have one which is straight, very straight from top to down, so something like this. And then I have another line which is very horizontal. So okay, very good. Now if we label this line A, this line B, and then this line C, and this D, what can we say about the gradient of these lines? Now if you look at line A is inclined, okay, so it is starting from a lower y and then x value, and it is ending at a higher x and y value. Okay, now from here it means that we can easily identify our gradient over here, which will be the x and y value here at the top will be bigger than the x and y value at the initial position. So we are going to have the gradient m for line A will be positive, because the change in, we are saying the gradient is y2 minus y1 over x2 minus x1. And if you look at it, here is where we have x2 and then y2, and they are definitely bigger. Once they are bigger than the x1 y1, we are expecting our gradient to be a positive gradient. Now on the contrary, if you look at B is coming down, okay, it is going downhill, so it means it is starting from here and then ending here. So your x2 y2 is the point over here, and this point over here becomes your x1 y1. Now over here, if you look at it, you realize that for the line B, x2 and y2 are small. Now if x2 and y2 are smaller than x1 and y1, it means that the gradient will be negative. So we'll have, so gradient for line B is negative, since the line is going downhill. So whenever you see a line like this and you have to calculate the gradient, be expecting that your gradient is going to be negative. Now let's look at C. Now if you look at line C is horizontal. So you have your x1 y1 here, you have your x2, and y2 is still the same. Okay, so if y2, let's say here is 1, then it means here will be, let's say x is 1 here, here it is 4, here it is 1. So it means our coordinates here over here will be 1 1, and then our coordinates here will be 4 1. If you look at it, we have y2 minus y1 over x2 minus x1. That will be our gradient for line C. And we have over here our y2, which is this second y over here, is 1 minus y1, which is the one over here, over x2, which is 4, minus x1, which is 1. So we are going to have 0 over 3 over here, and any number divided 0 divided by any number will give us 0. So if we have a horizontal line, we are expecting the gradient m for line C to be 0. Okay, so it's going to be 0. Now if you have a vertical line, this is going to switch. Okay, this is going to switch because the x value is now the same, and then the y value is what differs in this case. So the y value is now what differs, so it means that we are probably going to get our gradient to be equal to, let's say I still use the same points, okay, just for example's sake, it means we are going to have 3 here divided by 0. It's going to be the opposite of the horizontal one. Now when that happens, 0 cannot divide any number, so 3 over 0 will give us an infinite. We'll have an infinite number, so the gradient will be infinite when we have a vertical line given to us. Alright, so with this basic introduction to how to calculate the gradient of a line and what to expect when you are given a particular line slanted in any particular direction, let's go ahead and calculate the gradient for the following pair of points. So we have to calculate the gradient for the following pair of points. A and B. So we are given our A to be 0, 1, our B to be 2, -3, then we have our A to be -6, 3, our B to be 6, 3, and then we have our A is 3, 2, and then our B is 4, -1. Alright, so let's go ahead and calculate the gradient for this particular example. So solution. Now the first thing I do, and the first thing I recommend that you also do, is that you write your A, which is 0, 1, and then you write your B, your points, 2, -3. Now on top of your paper, okay, just write on top very small x1, y1 for the first point, and then x2, y2. Like that, there's no way you'll be confused with which one is x1, which one is x2, which one is y1, which one is y2. There's no way, because you've already labeled them. So my gradient for this case will be m is equal to, I quote my formula, y2 minus y1 over x2 minus x1. So this is equal to, my y2, I can tell straight away is that it's -3. I don't need to think. So I have -3 minus this minus, then y1 is 1 here, over x2 is 2 minus x1, which is 0. So this will give me -4 divided by 2, and the gradient over here will be -2. So for the first example, our gradient is -2. Now let's look at the second one. So as usual, I'll write my points, -6, 3. I write my B, 6, 3. Now because I don't want to be confused as to what is my x1 and y1, I label them. So the first point will be x1, y1, then x2, y2. Then I can go ahead and write my gradient formula. M is equal to y2 minus y1 over x2 minus x1. This is equal to, my y2 is 3 here, minus my y1, which is also 3, over my x2, which is 6, minus my x1, which is -6. So this will give me 0 divided by 12, and this is equal to 0. Okay, so therefore this is our gradient for this particular line. Now if you look at it really well, since our gradient is 0, it means this line is a horizontal line. Okay, it's horizontal because you can see the x has the same, irrespective of the coefficients of the number, negative, positive, it is lying on the same plane, it is horizontal. So this line, if you draw it on the Cartesian plane, it will be a horizontal line. All right, I. So let's have our gradient here. So we have our point A is 3, this is 2, our B is 4, negative 1. So this is my x1, my y1, my x2, my y2. So I can go ahead and write my gradient formula, which is y2 minus y1 over x2 minus x1. So this is equal to, this is my y2, so I have minus 1 minus y1, which is 2 over here, so I have 2, over x2, which is 4, minus x1, which is 3 over here. So I have here minus 1 minus 2 will give me minus 3, 4 minus 3 will give me 1, so this is equal to minus 3. So therefore my gradient for the third example is minus 3. All right, now let's have a look at another example. This is actually a practical example. So we have the line joining the points P into bracket 3 minus 4 to Q, small q 0, has a gradient of 2. We are to find the value of q. All right, so let's go ahead and write down our solution for this particular problem. Now if you look at the question, we said we have the line joining the point P, which is 3, negative 4, to Q. We have an unknown variable and 0, is said to have the gradient m. Okay, so the first thing I will do is I write my point P, which is 3, negative 4, and then I have my Q, which is my small q, and then 0. Then as usual, I will indicate on top here, this is my x1, this is my y1, this is my x2, this is my y2. Now from here, I was told that the line has a gradient of 2. So I quote my gradient formula, which is m is equal to y2 minus y1 over x2 minus x1. Now all I need to do is to do my substitution and solve mathematically to find the value of q. So the gradient in the question has been given to us to be 2, is equal to my y2 is 0 minus y1, which is negative 4, so I have negative 4 here, on my x2 is q minus my x1, which is 3. So from here I can go ahead and solve. So I cross multiply from here, this has a denominator of 1, so I cross multiply. So the 2 multiply q minus 3, and this is equal to 0 minus minus 4 will give me positive 4. So from here I can expand the bracket. So let me rewrite this. It's equal to 4. I need to expand the bracket. So I have here 2q minus 2 multiplied by 3 will give me 6 is equal to 4. So I have 2q is equal to this 4. I send the negative 6 to the other side of the equal to sign, it becomes plus 6. So I have 2q is equal to 10. I divide both sides by 2 to make my q stand alone, and so the value of my q will be 5. So therefore it means that my point capital Q is 5, 0, and the value of my small q as demanded by the question is 5. So thank you so much for watching. This is how we solve problems on how to find the gradient of a line. This is just a basic intro. We look at how to use 2 points to calculate the gradient, and how you can apply when you are given the gradient. You are given 1 point and you have to find another point. As we saw in this last example, we saw how to do that. First of all, you code the gradient formula, you do your necessary substitution, and then you solve a little bit of mathematics to find the value that you need to find for your other point. So thank you so much for watching again, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at parallel and perpendicular lines in coordinate geometry. So without further ado, let's begin. So we want to first of all look at the first diagram that we have here, which we are describing as parallel lines. So if we have two straight lines that are adjacent to each other and are either moving in the same direction or in the opposite direction, but they will never meet at any point, then we say these two lines are parallel to each other. Now these two lines, assuming you take a point here, let's say point A, and then another point here, point B, and then you take another point on the second line over here, let's say C, and another point here, D. If you calculate the gradient for the first line, the gradient will be equal to that of the second line. So we say for parallel lines, the gradient M1 for line 1 will be equal to the gradient M2 for line 2 because they are parallel. Now for perpendicular lines, we have these two lines crossing each other, making an angle of 90 degrees. So as you can see over here, we have an angle of 90 degrees over here. So if we have two lines crossing each other at an angle of 90 degrees, then we can describe those two lines as perpendicular lines. Now if we calculate the gradient M1 for line 1 and calculate the gradient M2 for line 2, we realize that if we multiply these two gradients, we'll get -1 for perpendicular lines. So it means for parallel lines, their gradients are equal, whilst for perpendicular lines, if you multiply their two gradients, you get a -1. Now let's go ahead and look at some problems on how parallel and perpendicular lines can be applicable in solving problems. So we have A and B are points 2, 5 and 6, 3 respectively. We have to find the gradient AB, the gradient of line perpendicular to AB. Alright, so let's go ahead and look at the solution for this problem. So we have solution here. We have line A, point A, which has the coordinates 2 and 5. And then we have point B with the coordinates 6 and 3. Now, for me not to be confused, I will label my coordinates. So this is my x1, my y1. This is my x2, my y2. So that when I'm solving, it is easier for me to easily pick my coordinates. Now, the first part of the question is demanding that I find the gradient AB. So the gradient of the line AB. So the gradient M of the line AB is given as the change in the y-axis. So that is y2 minus y1 on x2 minus x1. So this is equal to my y2 over here is 3 minus my y1 is 5 on my x2 is 6 minus my x1, which is 2. So I have from here -2 at the top on 4, and this will give me my gradient to be equal to -1 on 2. So my gradient M for the line AB is equal to -1 on 2. Alright, so the II aspect is saying the gradient of a line perpendicular to AB. Now, assuming this is the line AB, and then we have another line perpendicular to it, it means that line will cross the line AB, making an angle of 90 degrees. And like we saw in the previous example, or in the previous explanation that I gave, we said that if we have the gradient of 1, if we multiply it by the second one, because they are perpendicular, they should give us -1 as their product. So I'm going to say this is M1, so that is the gradient of line AB. So my M1 multiplied by M2 should give me -1. So if I make m2 the subject and I substitute the value of m1, which is the gradient of line AB, I should be able to get the gradient of the line perpendicular to AB. So let's go ahead and look at that. So my m2 here will become -1 on m1. So my m2 is equal to -1 on -1 on 2. This is equal to -1, which is the top here. To change the division sign to multiplication, I reciprocate what I have here, so it becomes 2 on 1, -2 on 1. So 1 multiplied by -2 on 1, which is equal to -2. So m over here will be equal to -1 multiplied by -2, and that will give me a +2. So the gradient of the line, let's say this line m2, the gradient of the line m2 over here is equal to 2. Alright, let's have a look at another example. We have to show that the lines joining P, points P 27, Q 32, and R 05 form a right angle triangle. Alright, so this is the diagram showing the points P, R, and Q, and then our axis. So let's look at the solution for this problem. Now, if we look at the diagram that we have very well, the question is demanding that we show that the lines joining P, Q, and R form a right angle triangle. Now, if you look at that, the only two lines that can give us a right angle triangle is the line PR and then RQ. That is, the angle over here should be 90. If the angle over here is 90, it means line PR, which is P and R over here, and line RQ are perpendicular. And because they are perpendicular, we are expecting their gradient to give us a -1 when we multiply them together. So let's go ahead and calculate their gradient and see that. So the gradient of PR, line PR, will be equal to y2 minus y1 on x2 minus x1. As usual, I'm going to write my points 2, 7, my Q 3, 2. So I have PR. So this is P, then write R over here. So R is 05. So this is for the first line P and R. So P and R over here. The second one is R and Q. So let me erase this. So for R and Q, their point R. For R, I have 05, and then for my Q, I have 3, 2. Alright, so I can now go ahead and label my points. So I have, this is my y1. This is my x2, y2. That means from P to Q. P is the first point, Q is the second point. So these are my coordinates. So from R to Q, R is my first point. So this is x1, y1. This is x2, y2. Okay, so for my line PR, my y2, this is y2. My y2 is 5, so I have 5, minus my y1 is 7, on my x2 is 0, minus my x1, which is 2. So this is equal to 5 minus 7 will give me -2, on the denominator over here also give me -2, and this is equal to 1. Alright, so the gradient of the second line, which is R and Q, will also be equal to y2 minus y1 over x2 minus x1, and this is equal to my y2 here is 2 minus my y1 at the top, which is 5, over my x2 is 3 minus my x1, which is 0. So I have over here, from the top I have 2 minus 5 will give me -3, denominator will give me 3, and this is equal to -1. Now we said that if it is true that the lines joining PQ and R form a right angle triangle, then we are expecting the line PR and RQ to be perpendicular, which means if we multiply their two gradients, that should give us -1. So the gradient of PR multiplied by the gradient of RQ. The gradient of PR is 1 multiplied by the gradient of RQ is -1, and this is equal to -1. So because we have -1, it shows that the line PR and the line RQ are perpendicular to each other, and therefore all these 3 points join together to form a right angled triangle. So thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, I want to look at how to calculate the distance between 2 points in coordinate geometry. So without further ado, let's begin. So assuming we have a point A with the coordinate x1, y1, and another point B with the coordinate x2, y2. We got these coordinates by extending these lines. So let me quickly show you guys that. So if we extend the line over here, we'll get an x value over here. If we extend this also to the bottom, we get an x value over here. So the initial x value over here is what we are saying is x1. Then the final x value is what we are saying is x2 over here. And then if we extend this line as well, we get the initial y value of this line, so that is y1. And then if we extend the one at the top over here, we can get a point over here, so we have y2. Now for us to be able to calculate the length or the distance between the point A and B, we need to know the distance between this point. Okay, so we extend these lines to come and join each other over here. So the distance on the x-axis, we need to know that. Then we know the distance on the y-axis as well. Then we use the Pythagoras theorem to find the distance from the point A and B. So let's look at how we do that. The distance from the point x1 to x2 over here will be the difference between the higher value of x, which is x2 over here, minus the lower value of x. So the distance over here from x1 to x2 will be x2 minus x1. So the vertical distance over here will be y2 minus y1. So we need to subtract this from this to get a distance from the top to the bottom over here. Now what happens if we want to find the distance of AB? So AB, the length or the distance of AB, we use Pythagoras theorem. So according to the Pythagoras theorem, the hypotenuse square, which is the length AB, so we have the length AB squared, would be equal to the length of, let's say this is C, so it will be equal to the sum of the length AC and BC squared respectively. So we'll have AC squared plus BC squared respectively. So this means the length AB squared will be equal to the length of AC, as I showed earlier on, is x2 minus x1 squared, plus for B and C it will be y2 minus y1 all squared. So now to leave the length of AB stand alone, we have length of AB, then we take the root of what we have on the right hand side. So we have x squared minus x1 squared plus y2 minus y1 squared. So this becomes the formula for calculating the length or the distance between 2 points. Now let's go ahead and have a look at some examples to further appreciate what we are talking about. So we have the point A and B are points 2,5 and 6,3 respectively. We are to find the gradient of the line AB, the gradient of the line perpendicular to AB, and then the length of AB. Okay, so let's write down our solution. So we have the point A with the coordinates 2 and 5, and then the point B with the coordinates 6 and 3. So this is my first x value, my first y value, so x1, y1. This is x2, y2. So now that I have this, I can go ahead and easily find my gradient. My gradient, or the slope of AB, represented by m, will be equal to the change in the y-axis to the change in the x-axis. So this is equal to my y2 is 3 minus my y1 is 5, all on my x2 is 6 minus x1, which is 2. So this gives me 3 minus 5 will give me a negative 2, and then 6 minus 2 will give me 4. So this is equal to negative 1 on 2 as my gradient for the line AB. Now, the gradient of the line perpendicular to AB. So now we said for perpendicular lines, if you multiply their gradient, you should get negative 1. So assuming the gradient over here is m1, if I multiply m1 by the gradient m2, which is the line perpendicular to the line AB, I should get the result to be negative 1. So if that holds true, then it means that m1, m2 is equal to negative 1, and therefore negative 1 on 2 multiplied by m2 should be equal to negative 1. So I have a fraction here, I need to get rid of it. So I multiply both sides by 2. So I have 2 multiplied by negative 1 on 2, m2 is equal to negative 1 multiplied by 2. This will cancel this. I have negative m2 is equal to negative 2. I divide both sides by negative, and I have my m2 to be equal to 2. So therefore, it means the gradient of my line perpendicular to AB is 2. Alright, so let's go ahead and calculate the length AB. We said to calculate the length of 2 points, say AB, that will be equal to the root of s2 minus x1 squared plus y2 minus y1 squared. So the length of AB is equal to the root of my x2 is 6 minus x1, which is 2 squared, plus my y2, which is 3 minus y1, which is 5 squared. The length of AB will be equal to 6 minus 2 will give me 4 squared, plus 3 minus 5 will give me a negative 2. So I have negative 2 squared. So the length AB is equal to the root of 4 squared is 16 plus 2 squared is negative 2 squared is 4, and this is equal to the root 20. So therefore, the length of the point AB is root 20. And because we don't know the unit in which the axes were labeled, we can just say root 20 units. So if it is in meters, it is root 20 meters. If it is in centimeters, it's root 20 centimeters. Since we don't know the unit in which they are measuring the length of this particular point A and B, so we just add units attached to it. Alright, so let's go ahead and look at another example. So for the points P into bracket X, Y, and Q, 3x, 5y, we are to find in terms of x and y, I, the gradient of the line PQ, and then II, the length of the line P and Q. So let's go ahead and look at the solution for this problem. So we have the point P, which has x and y, and then we have our second point Q, 3x, 5y, we are to find in terms of x and y the gradient PQ and then the length PQ. Okay, so as usual, I will always write my x1, y1, x2, y2 over here for ease of calculation. Then I can go ahead and say I, the gradient of the line PQ, which is m of PQ, will be equal to y2 minus y1 on x2 minus x1. So this is equal to my y2 is 5y minus my y1 is y, my s2 is 3x minus my x1 is just x. So I have over here 5y minus y will give me 4y on 3x minus x will give me 2x. So this is equal to 2 will go here, 1 go here, 2. So our final answer is 2y on x as the gradient of the points P and Q. So let's look at II, the length PQ. So the length PQ will be equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So this is equal to the root of x2 minus x1, let me just pick it over here, will be equal to 3x minus x squared plus my y2 minus y1 is what I have at the top over here. So I have 5y minus y squared. So from here, 3x minus x is the 2x I had over here. So I have 2x squared plus I have 4y over here squared. So this is equal to the root of 2s squared will give me 4s squared plus 4y squared will give me 16y squared. So my final answer, which is the length of PQ, will be equal to the root of 4s squared plus 16y squared unit. Like I said, since we are calculating the length of the line PQ, the length is always measured in a certain unit, whether it is in meters, centimeters, kilometers, we don't know. So we add the unit to let the teacher knows that we are still thinking about the unit that the length is being measured in. So thank you so much for watching. This is how we calculate the length or the distance of 2 points when we are given in a question. So thank you once again for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the midpoint of a line joining 2 points. So without further ado, let's begin. So assuming we have the point on the line, point A, as we can see over here, and another point B. So point A has the coordinates x1 and y1. Point B has the coordinate x2 and y2. And we are to calculate the midpoint M, which is shown over here. So let's say this is the middle of this straight line. We are to calculate the coordinate or the points of the midpoint over here. How do we do that? Now the midpoint over here, which is the middle of the line AB, if this were to be on a graph, you can easily just trace the y and then the x values like this, and you can easily get your answer. So you have your x value over here, then you have your y value over here, and then that means your point M will become your x that you have here. Let's say this is xa and this is yb, so it will become sayb. Now what happens if this is not on a graph? You were just given a straight line and then you were asked to find the midpoint of these 2 points. How do you do? So to find the midpoint, this is what we do. So we say midpoint MD is equal to, all you have to do is that you want to find the x and then the y component of this middle point over here. So it is safe for you to add the x component over here to the x component over here, find half of it, and then you add the y component and also find half of those points or coordinates. So to find the midpoint is equal, so you have into bracket x1 plus x2 divided by 2, which means you add the distance, you add these 2 points, point x1 and x2 to get the distance over here, x1 and then y2 to get that distance. Then you find half of it, so it becomes x1 plus x2 on 2, comma, then you have y1 plus y2 on 2. Okay, so if you add these 2 points, x1 and x2, you find half of it, y1 and y2, you also find half of it. That will give you the coordinates of the center of that particular line A and B. Alright, so now that we know the formula for calculating the midpoint of 2 points, let's go ahead and have a look at a question to further understand what we are doing. So we have a full set of questions here. We have, for the following pair of points A and B, we have to calculate A, the gradient of the line AB, B, the midpoint of the line joining A and B, C, the distance AB, and then D, the gradient of the line perpendicular to AB. Now, in our previous video, we did look at how to calculate the gradient of a line, the distance of a line, and what it means to have a perpendicular or a parallel line. So I'll be leaving the link to those videos in the description. If you have not watched them, you can go and watch them so you understand how to calculate the gradient, distance, and perpendicular lines. But I will be explaining them in this video as well. Alright, so let's write down our solution. So we have the first point I. This is the A, the point A and its coordinate, the point B and its coordinate. So let's look at, for I, we have A with the coordinate 4 and 3, and then B with the coordinates 2 and 0. Okay, let's go ahead and label that. So since we are finding the gradient AB, the midpoint A to B, it means our first point is A. So our x1, y1 will be these two values, and then this will be our x2, our y2 as well. So the first thing to do is A, our gradient of the line AB. So M, which is the gradient, is equal to y2 minus y1 on x2 minus x1. This is equal to my y2 is 0 minus my y1, which is 3, on my x2, which is 2, minus my x1, which is 3. So this is equal to negative 3 at the top. Sorry, my x1 is 4. So negative 3 at the top on 2 minus 4 will give me a negative 2. So this is equal to 3 on 2. So my gradient for these 2 points A and B is 3 on 2. Now B, the midpoint MD, the midpoint will be equal to x1 plus x2 on 2, y1 plus y2 on 2. So this is equal to my x1 is 4 plus my x2 is 2 on 2, my y1 is 3 plus my y2 is 0 on 2. So I have here 6 on 2 and then 3 on 2, and then this will give me 6 on 2 is 3, and then 3 on 2, you can either maintain it 3 on 2 or you write 1.5. So I'm going to maintain it as 3 on 2. So this is my midpoints for the line A and B. Now C, let's calculate the distance AB. So to calculate the distance AB, this is equal to the root of s2 minus x1 squared plus y2 minus y1 squared. Now we explain why this is the case in how to calculate the distance video tutorial. So like I said, you can check the link of the description and see that video. So the length AB will be equal to the root of my x2 minus x1. I can just pick it over here, very easy for me, I've done that already. So that will be 2 minus 4 squared plus my y2 minus y1 is what I have at the top here, so it's 0 minus 3 squared. So my AB is equal to the root of 2 minus 4 will give me negative 2. So I have negative 2 squared plus negative 3 here squared. So AB is equal to the root of negative 2 squared will give me 4 plus negative 3 squared will give me 9, and then the length AB is equal to root 13, and so my answer for the distance AB will be equal to root 13 units. Like I said, the length or the distance is always measured in a particular unit, whether in meters or kilometers, we don't know, or centimeters, we don't know. But because we don't know, we just add unit to show that if it is in meters, it's root 13 meters. If it is in centimeters, it's root 13 centimeters. All right. So now that we've done calculating the distance, let's look at the gradient of the line perpendicular to AB. Okay, so the gradient of the line perpendicular to AB. So for perpendicular lines, if you multiply their gradient, let's say m1 multiplied by m2, that should give you -1. So it means if I multiply the first gradient I have, which is the gradient of AB, with the gradient that I want now, I should get -1. So therefore, it means that to get my gradient m2, which is the gradient of the line perpendicular to AB, my m2 will be equal to -1 on m1, and that will be equal to m2 is equal to -1 on 3/2. And then if you reciprocate this and you calculate that, you are going to get -2/3 as the gradient of the line perpendicular to AB. Alright, so let's go ahead and look at the II aspect, which has the points A, 1, 4, and then B, 1, -2. Okay, so II, the A has the point 1, 4, and then the B has the point 1, -2. As always, I'll always label my points or my coordinates. So this is my x1, my y1, my x2, my y2. Alright, so the first thing we have to calculate is the gradient m, which is equal to y2 minus y1 on x2 minus x1. So my y2 here is -2 minus my y1, which is 4 here, on my x2, which is 1, minus my x1, which is also 1. So this is equal to -6 on 0, and then any number which is divided by 0 will give us an infinity. So the gradient over here is infinite. Alright, let's look at B, the midpoint of the points A and B. So the midpoint MD is equal to S1 plus S2 on 2, comma, Y1 plus Y2 on 2. So that will be equal to X1 is 1 over here, 1, plus X2 is also 1, so on 2. And then my Y1 is 4, plus my Y2 is -2 on 2. So this will give me my midpoint to be equal to 1 plus 1 is 2 on 2, comma, 4 minus 2 is 2 on another 2. So therefore my midpoint for the point A and B is 1, 1. Alright, so C, the distance AB. So the distance AB is equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So this is equal to the root of my s2 is 1 minus my x1 is also 1 squared plus my y2 is -2 minus my y1 is 4 squared. So this is equal to 1 minus 1 is 0, so we square that, plus into bracket we have -2 minus 4 is -6 squared. So this will give us the root of 0 squared is 0, and then negative 6 squared will give us 36. So the distance AB is root 36 units. Alright, now let's look at the last aspect of this question D, which is saying the line perpendicular to the points A and B. So we have, for perpendicular lines, we know that if we have the gradient m1 multiplied by m2, we should get -1, which is the negative reciprocal. So it means that, so I'm going to do the D over here. It means that my m2, which is the gradient perpendicular to the first gradient I found over here, will be equal to -1 on m1, and that is more like m2 is equal to -1 on -6 on 0. Let me use this instead of using the infinite over here. So that means my m2 is -1 multiplied by 0. If you interchange here, to be 0 on -6, and -1 multiplied 0 divided by any number is 0, and so -1 multiplied by 0 is 0. So the gradient m2, or the gradient of the line perpendicular to the line AB, is 0, but the gradient of the line AB itself is infinite. So thank you so much for watching this video, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at what collinear points are. Alright, so let's begin. Now if we look at this diagram, we have some lines that are joined in a pattern to form this 4 squared shape, and then we have another line from the middle, A to C. Now there are some points on this line, so we see point A, B, C, D, E, F, and G. Now let's now define what collinear points are. Collinear points. So when we talk about collinear points, they are points that can be found together on a straight line, or they are points that lie on the same line. So it means if I take, let's say, line AB, I can see point A, point G, and then point B on that line. So the points A, G, and B become my collinear point because they can be found on a straight line. Now if I look at A, E, and C, that is also another straight line, and there are 3 points on it. So I also have A, E, and C. These are also collinear points. If I look at the line, let's say D, F, and C, they are also collinear points since we have all those points on one straight line. B and C are also collinear points because they are points on a straight line, so B and C. The same way we have A and D are also collinear points. So basically, collinear points is just, you have a straight line, you have points, let's say A, B, and C on it, they become collinear points. Now if you have 2 lines joined together and one point is here, one point is here, let's say this is D and this is X. Now these 2 points are not collinear points because they are not on a straight line, but they are on different lines, so they are not collinear points. Now let's look at how we determine whether some points are collinear or not. Now there are 3 ways to do that. The first one is to use the distance formula, which is what we'll be looking at in today's video, and in the subsequent video we'll be looking at the other ways of calculating collinear points. The second way to do that is to use the slope formula or the gradient formula. And then the last way of doing this is the area of triangle formula. But like I said, for the purpose of this tutorial, we will be looking at the distance formula. Now, for the distance formula, if let's say we have point A, B, and C, let's say this is a straight line, we have a point, let me use different color. So we have a point here A, another point here B, and another point here C, and this point A, B, and C are said to be collinear. Then it means the distance AB plus the distance BC should be equal to the distance AC. So I take that again. So if the point A, B, and C are collinear, it means the distance AB, so AB here, and then the distance BC, if we add the two, it should be equal to the distance AC at the bottom over here. Now we know that to calculate the distance of 2 points, let's say A and B, this is equal to the root of the coordinates x2 minus x1 squared plus y2 minus y1 squared. So this is the distance formula, and this is what we'll be using to calculate what collinear points are. Alright, so with this basic introduction, let's go ahead and look at some questions on collinear points. So we are to find if the points x, y, and z are collinear given their points -3, -1, -1, 0, and 1, 1 respectively. Alright, so let's write down our solution. So we have the points x with the coordinates -3, -1, and then we have the point y with the coordinate -1 and 0, and then we have the last point z, +1, +1. Alright, now we were asked to find if the points x, y, and z are collinear. Now because we are using the distance formula, it means that if the point x, y, and z are collinear, then the distance of xy plus the distance of yz should be equal to the distance xz. So it means the distance from the point x to y and the distance from the point y to z should be equal to the distance from x to z. Alright, so let's look at how to calculate that. So I'll do it step by step. So let's calculate the distance xy. So the distance xy is equal to, and we have into bracket, x2 minus x1 squared plus y2 minus y1 squared. Now let me label my coordinates. So this is my x1, y1 in this case, and this is my s2, y2. So that means that I have over here my s2 is -1 minus my x1 is -3, so it becomes -3 here squared, plus plus my y2 here is 0 minus my y1, which is -1, so -1 squared. So this becomes -1 minus -3, that will become plus. So -1 plus 3 will give us 2. So I have 2 squared here plus this is +1, -1 is +1, and then +1 squared over here. So I'm going to have 2 squared is 4, and then 1 squared is 1. So I'm going to have √5 as my answer over here. So the distance xy is √5. Alright, so let's go ahead and calculate the distance yz. So the distance yz is equal to, I have root of x2 minus x1 squared plus y2 minus y1 squared. Alright, so in this case, because we are starting with a point y and z, then this now becomes my x1, my y1, this becomes my s2, my y2. So this is equal to the root of my s2 is 1 minus my x1, which is -1, so -1 squared, plus my y2 is 1 minus my y1 is 0 squared. So this is equal to 1 minus -1 will give me 2, because this becomes plus, so it becomes 2 squared here plus into bracket 1 squared, and this is equal to 2 squared is 4 plus 1 squared is 1. This gives me √5 as my answer. Now this is root 5, this is root 5. So it means that just before we calculate the distance x, z, it means that root 5 for xy over here plus yz, which is also root 5, this will give me 2 root 5 as my answer. So I'm expecting that my distance xz will be equal to 2 root 5, and if that is the case, then I know that my 3 points x, y, and z are collinear. Alright, so let me go ahead and calculate the distance xz. So I'm just gonna erase this and this guy. Okay, so the distance xz will also be equal to the root of x2 minus x1 squared plus y2 minus y1 squared. So the distance xz will be equal to, now because my x is the first coordinate over here, my first point over here, the coordinates here become my x1, this becomes my y1, and because the second point is z, this becomes my s2, y2. So I have over here the root of x2, which is 1, minus x1, which is negative 3, squared, plus my y2, which is also 1, minus my y1, which is also negative 1, squared. So the distance xz is equal to the root of 1 minus 3, that will give me 4, so 4 squared, plus 1 minus 1 will give me 2 squared. So I have over here 4 squared is 16 plus 2 squared is 4, and if I add this, this will give me root 20. Okay, and root 20, you can solve it as basically this is like 4 multiplied by 5, and then the root of 4 is 2, so you bring that outside, so it becomes 2 root 5. So this is our answer. We have 2 root 5 as our answer. Because the distance xz is 2 root 5, and then the distance xy plus the distance yz is also root 5 root 5. If you add, you get 2 root 5. It therefore concludes that the points x, y, and z are collinear. Alright, so let's have a look at another example. We are to show that the 3 points P 24, Q 46, and R 68 are collinear. Alright, so let's write down our solution. Now, for us to show that the points P, Q, and R are collinear, it means the distance between PQ plus the distance between QR should be equal to the distance PR. Alright, so I'm going to do this straightforward. So the distance PQ will be equal to the root of s2 minus x1 squared plus y2 minus y1 squared, then plus the root of same thing, x2 minus x1 squared plus y2 minus y1 squared, to be equal to the root of s2 minus x1 squared plus y2 minus y1 squared. Now when you're doing this, be very careful not to confuse the coordinates of your point. Alright, so let me take PQ first. Yes, P and Q. So let me do that first. So if I do that, this becomes my x1, my y1. This becomes my s2, my y2. So this will be equal to the root of my s2 is 4 minus my x1 is 2 squared plus my y2 is 6 minus my y1 is 4 squared. Now plus, okay, so I can go ahead and erase these guys. Okay, now I'm at QR, so that will be equal to the root of, for QR, this becomes my x1, y1 s2 y2. So my s2 is 6 minus my my x1 is 4 squared plus my y2 is 8 minus my y1, which is 6 squared, is equal to the root of, okay, so now I carefully erase this. Okay, I can maintain that. So this will still be my y2. This becomes my x1, my y1 now, since I'm using p and r. So my s2 is 6 minus my x1, which is 2 squared, plus my y2, which is 8 minus my y1, which is 4, now squared. So this becomes the root of 4 minus 2, that will give me 2, so it becomes 2 squared, plus 6 minus 4 will give me 2 squared, plus the root of 6 minus 4 will give me 2 squared, plus 8 minus 6 also give me 2 squared. This is equal to, then I come to this side, 6 minus 2 will give me 4 squared, plus 8 minus 4 will give me 4 squared. So I have over here 2 squared plus 2 squared, so this will give me 4, this will give me 4, and that will be root 8 at this point. So I have over here root 8 plus this will also give me root 8 is equal to, this side will give me 4 squared is 16 plus another 4 squared, which is also 16, so that will give me root 32, and then root 32, say this is root 8 plus root 8 is equal to, root 32 can be written as 4 multiplied by 8, because 4 multiplied by 8 will give me 32, and I know the root of 4 is equal to 2, so this becomes over here root 8 plus root 8 is equal to the root, this will become 2 squared, so it will take care of the root, so it comes outside 2 root 8. So we can see that root 8 plus root 8 is equal to 2 root 8, and because PQ plus QR, which is root 8 plus root 8, is equal to 2 root 8, we therefore conclude that the points P, Q, and R are collinear. Now if you look at it very well, over here, this can also be your answer, but we try to rewrite it in a way that it is easily visible for you to understand. So you try to rewrite it to have the same number under the root, so root 8, root 8. So you try to convert your root 32 to root 8 so that it can be easily identified. So over here we have root 8 plus root 8, so this side will give us root 8. So let me do that. So root 8 plus root 8 will give us 2 root 8, and this is equal to this side, which is also 2 root 8. So we can see that the left hand side is equal to the right hand side, and so the points P, Q, and R are collinear points. So thank you so much for watching, and in the next video we'll be looking at how to calculate collinear points using the gradient or the slope formula. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at collinear points using the slope or the gradient formula. So without further ado, let's begin. Now in our previous video, we did look at what collinear point is. We said that collinear points are any point that can be found on a straight line. So assuming we have this straight line, so let's say we have a point here, say point A, we have another point here, point B, and then another point here, point C. We say that these 3 points are collinear points because they are found on a straight line. Now to be able to identify if 3 points are collinear points, there are 3 different ways we do that. We can either use the distance formula, which we saw in our previous video. The second way to do that is to use the slope or the gradient formula. And then the last way to do that is to use the area of a triangle approach or formula. Alright, so in this video we'll be looking at the second part, which is the slope or the gradient formula. Now if 3 points are collinear points, it means that the gradient of any of those 2 points should be the same. I take that again. If let's say the points A, B and C are collinear, then the gradient of any of these 2 points should be the same. So it means if I calculate the gradient of, let's say, point AB, it should be equal to if I calculate the gradient of point BC, and it should be equal to if I calculate the gradient of AC. So if the gradient of AB is 1, then I expect the gradient of BC to also be 1, and then the gradient of AC to also be 1. Alright, so this is how we find whether 3 points are collinear or not. Now, just a little recap. To find the slope or the gradient of 2 points, which is given by M, this is equal to the change in the y-axis, which is y2 minus y1 over s2 minus x1. So this is basically the change in y-axis on the change in x-axis. So this is the formula for calculating the gradient of a line of any 2 given points. Alright, so let's look at an example. We are to show, using the slope formula, that the 3 points P 24, Q 46 and R 68 are collinear. Alright, so let's go ahead and look at the solution to this problem. Alright, so they are saying we should show, using the slope formula, that the 3 points PQ, so I have P 24, my Q 46, and then R 68 are collinear. Now if these 3 points, if P, Q and R are collinear, then the gradient of the point PQ, that is P and Q, if you find the gradient of these two, it should be equal to if you find the gradient of Q and R, and it should be the same if you find the gradient of P and R. Alright, so let's go ahead and find the gradient of each of these points. So the gradient of PQ will be equal to y2 minus y1 on x2 minus x1. So let me label my coordinates. So this becomes, since P is my first point, it becomes my x1, y1. This is my s2, y2. So my y2 is 6 minus my y1, which is 4, on my s2, which is 4, minus my x1, which is 2. So this gives me 6 minus 4 is 2, on 4 minus 2 is also 2, and this is equal to 1. So the gradient PQ is 1. Alright, so let's go ahead and calculate the gradient for QR. The gradient for QR will be y2 minus y1 on s2 minus x1. Alright. Now in this case, because now I am looking at Q and R, my Q becomes my first point, so this becomes my x1, y1, this becomes s2, y2. Okay, so it means that my y2 over here is 8 minus my y1, which is 6, on s2, which is 6, minus x1, which is 4. So this is equal to 8 minus 6, that will give me 2. 6 minus 4 will also give me 2, and this is equal to 1. So already we can see that the gradient of the point PQ and the gradient QR are already the same. So let's confirm the last one, which is the gradient of the points P and R. So the last one, the gradient of PR. So in that case, our gradient will be y2 minus y1 on x2 minus x1 as usual. But this time around, let me erase this. This time around, because we are starting, our first point is P, it means that this becomes our x1, y1. Alright. So from here, we have my y2 is 8 minus my y1 is 4 on my s2 is 6 minus my x1, which is 2 over here. So this is equal to 4 on 4, and this is equal to 1. So we can see that the gradient of the point PQ is 1, which is equal to the gradient of the point QR, which is also 1, and which is equal to the gradient of the point PR, which is also 1. So because the gradient of PQ is equal to the gradient of QR, which is equal to the gradient of PR, we say that the three points P, Q, and R are collinear. So you can end your question by writing this statement to show that yes, because this is 1, and this is also 1, the 3 points are collinear. Alright, so let's go ahead and have a look at another example. So if A with the coordinate 5, 2, B 3, -2, and C 8, 8 are 3 points in a plane, check whether the points are collinear or not. Alright, so let's write down our solution. So you can go ahead and try calculating the gradient for the point AB, BC, and then AC to see if you will get the same answer for the gradient. Alright, so let's go ahead. So I'm going to write my points A 5, 2, my B is 3, -2, and then my C is 8, 8. As usual, I say if A, B, and C are collinear, then it means that the gradient of the points AB should be equal to the gradient of the points BC, and that should be equal to the gradient of the point AC. So the first thing I do is to calculate the gradient of my points AB. So for my point AB, this becomes my x1, my y1, my s2, y2. Okay, so my formula is y2 minus y1 on s2 minus x1. So this is equal to my y2 is -2 minus my y1, which is 2, on my s2, which is 3, minus x1, which is 5. So this is equal to -4 at the top on 3 minus 5 will give me -2, and this cancels this, so I have here 2 as my gradient over here. Alright, so let's go ahead and calculate the gradient of B and C. Okay. So for the gradient of BC, this is equal to y2 minus y1 on x2 minus x1. Because B is our first point, it means that this is my x1, y1, s2, y2. So this is equal to my y2 is 8 over here, as you can see, so I have 8 here, minus my y1 is -2, so I have -2, on my s2 is also 8, minus my y1 is 3. So this is equal to, at the top I'm going to have 8 plus 2, and that will give me a 10. On the bottom here, 8 minus 3 will give me a 5, and 10 on 5 will give me 2 as my answer. Alright, so let's go ahead and calculate the gradient of the last set of points, that is A and C, to see if we'll get the same result. So the gradient of the point AC is equal to, for AC, my A becomes my first point, so I have y1, x1, y1, and then x2, y2. Alright, so I can go ahead and quote my slope or gradient formula, which is y2 minus y1 on x2 minus x1. So this is equal to my y2 is 8 minus my y1, which is 2, on my x2, which is also 8, minus my x1, which is 5. So I have at the top over here 8 minus 2, that will give me 6, on 8 minus 3, sorry, 8 minus 5, that will give me a 3, and 6 on 3 will give me 2. So therefore we can conclude that the points A, B, and C are collinear since the gradient of any 2 points, let's say the point AB is 2, point BC is also 2, and point AC is 2. Since the gradients are the same, the points A, B, and C are collinear points. So thank you so much for watching. This is how we use the slope or the gradient formula to find if 3 points are collinear points on a straight line. Now in the next video, we'll be looking at how to use the area of a triangle formula to find if 3 points are collinear or not. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to learn how to find collinear points by using the area of a triangle formula. Now in our previous 2 tutorials, we did look at how to find collinear points using the slope or the gradient formula and the distance or the length formula. Now in today's video, we want to look at how to find if 3 points are collinear but using the area of a triangle formula. Now we said collinear points are 2 or 3 points that can be found on a straight line. So any point that can be found on a straight line, we said they are collinear points. So let's look at something. So assuming we have a straight line here, let me just draw a straight line. Assuming we have a straight line here, and we have one point here A, another point here B with their coordinates respectively, another one here C. Now if you look at these 3 points, there is no way you can join these 3 points to make a triangle. No possible way. But what if, let's say we have point A here and then point B in a straight line with it, but point C is slightly displaced downward, so it's not in line with A, B, and C, it's somewhere, let's say, slightly down here. So this is point A, this is point B, and this is C. If this becomes the case, you see that you can join, okay, that is a terrible line. So if that happens, you can see that you can join the point A to B, B to C, and then C to A to form some sort of triangle, whether isosceles, whether scalene, or right angle triangle. You could form any type of triangle if one of the points is displaced. But if all of them are in straight line, you cannot get a triangle. So the whole idea behind the triangle formula is that if 3 points are collinear, then the area of the triangle should be 0, because they will not form any triangle, so we are not expecting any value for the area of the triangle. But if they are not collinear points, then we should get a value for the area of a triangle. So suppose we have the points, let's say P, which has the coordinate x1, y1. Then we have another point Q with the coordinate x2, y2, and another point R with the coordinate x3, y3. Now using these 3 points, how do we use the area of a triangle formula to show that the 3 points are collinear? We do that by using the formula half, then we have like matrices. We have x1 minus x2, then we leave room, x2 minus x3, then we have here y1 minus y2, then we have y2 minus y1, sorry, y2 minus y3 here should be equal to 0. So this is a 2 by 2 matrix. We know how to solve a 2 by 2 matrix to find a determinant. So all we have to do is to solve this formula as a 2 by 2 matrix, find the determinant and then multiply it by half. If we multiply it by half and we get 0, then we know that those 3 points are collinear point and hence cannot form any triangle because they are in a straight line. So this is the formula we'll be using to find if 3 or more points are collinear. So let's go ahead and look at how to use this formula in real time. So we are to find if the point P 2, 3, Q 4, 0 and R 6, -3 are collinear points. So let's write down our solution. Now we know that we are using the area of a triangle formula and not the distance or the slope formula. So this time around, I'm going to write my P with the coordinates 2, 3. I write my Q 4, 0, and I write my R 6, -3. So from here, I'm going to label my coordinates. This is my x1, y1, s2, y2. This is my s3, y3. Alright, so we know that if P, Q, and R are collinear points, then it means that half, then we have x1 minus x2, s2 minus x3, y1 minus y2, y2 minus y3 should be equal to 0 since they are collinear points. So all we have to do from here is to do our substitution. So we have half multiplied by our x1 is 2 here, minus x2 is 4, then s2 is 4 minus x3, which is 6. This is equal to 0. Then my y1 is 3 minus my y2, which is 0, and my y2 is 0 minus my y3, which is -3. So this will be equal to, I have my half outside bracket, then 2 minus 4 will give me a -2, then 4 minus 6 will give me a -2, then I have 3 minus 0 will give me 3, and 0 minus 3 will become +3. So I have 3 here is equal to 0. Now you know that when solving matrices, 2 by 2 matrix, to find the determinant, you multiply the leading diagonal, which is these two guys first, and you subtract the other diagonal from it. So we are having half, then into bracket, we multiply the leading diagonal, so it will be -2 multiplied by 3 minus then the other diagonal, so it will be 3 multiplied by -2 over here, should be equal to 0. So I have here half into bracket, matrix bars. So -2 multiplied by 3 will give me a -6, minus this minus 3 multiplied by -2 will give me a -6 again. And so this is equal to half -6 plus 6, and -6 plus 6 is 0, multiplied by half is still 0, so this is equal to 0. And so because after solving everything over here we get 0, it therefore means that the points P, Q, and R are collinear. They are collinear since the area is equal to 0, since the area of the triangle is equal to 0. Alright, so let's have a look at another example to further understand what we are talking about. So we are to show that the points A, B, and C are collinear using the area of a triangle formula. Alright, so let's write down our solution. As usual, I'll write down my points. So I have 5, 2 for A, B with the coordinates 3, -2, and C with the coordinates 8 and 8. So I'll go ahead and label my coordinates. So this is my x1, y1, my s2, y2, my s3, y3. And so I know that if points A, B, and C are collinear and I'm using the area of the triangle formula, it means that half x1 minus x2, x2 minus s3, y1 minus y2, y2 minus y3 should be equal to 0. So over here I go ahead and do my substitution. So my s1 is 5 minus my s2 is 3, my s2 is 3 minus my s3, which is 8, is equal to my y1 is 2 minus my y2, which is negative 2. Then I have negative 2 as my y2 minus 8 as my y3. So from here I have half, then 5 minus 3 will give me a positive 2. 3 minus 8 will give me a negative 5. 2 minus minus 2 will give me a positive 4, since the negative negative becomes positive. And then negative 2, negative 8 give me a negative 10 over here. This is equal to 0. So I'm going to multiply the leading diagonal and subtract the second diagonal from it. So it will be, I have 2 multiplied by negative 10 minus then the adjacent diagonal 4 multiplied by negative 5 is equal to 0. So I have here half, and to bracket 2 multiplied by negative 10 will give me negative 20 minus 4 multiplied by negative 5 will give me negative 20. So I have here half multiplied by negative 20, negative negative becomes positive 20. So this is half multiplied by 0 is equal to 0, and so 0 is equal to 0. Alright, so because the area of the formula, the area of the triangle after calculating is equal to 0, we can therefore conclude that the points A with the coordinate 5, 2, B with the coordinate 3, negative 2, and C with the coordinate 8, 8 are collinear points, since the area of the triangle is equal to 0. So thank you so much for watching. This is how we calculate the collinear points to find whether the points, 2 or more points, are collinear using the area of a triangle formula. Alright, so I will see you in the next video where we'll be talking about the equations of a straight line given 1 point. So thank you once again, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the equation of a straight line when you are given only 1 point. Alright, so let's go ahead and look at how we do that. So assuming we have, let's say we have our axis over here. So this is my x-axis, this is my y-axis, and I have, let's say, a straight line over here, and I only know 1 point, let's say x and y, and I don't know any other point on this straight line, but I know the gradient to be, let's say, m. How do I find the equation of this particular straight line? Now there are 2 ways you can do that. You can first of all use the equation of a straight line formula, then get that, which is y is equal to ms plus c. This is the equation of a straight line. So from here, all you do is you substitute the values of x and y into this equation to find the c, which is the constant. So your y is your y coordinate, your x is your x coordinate, your m is your gradient or slope, your c is your constant, or the point at which the line cuts the y-axis. Right, so in the first case, if you are using this formula, you only substitute the value of x and y into this equation to find a constant, and then you substitute it back to find the equation of the straight line. Or another way you can find the equation of a straight line is to use the equation y minus y1 equals m into bracket x minus x1. Over here, your point become x1, y1. So you substitute the value of x in place of x1, y in place of y1. You already know the gradient. You substitute that, and then you do your calculation to get your equation of that particular straight line. Alright, so let's go ahead and look at an example. So we have to find the equation of a straight line with gradient 2 through the point 0, -5. Right, so I'll be using the 2 method in this case. So let me write down my solution. So I've been told that my gradient m is 2 and my point is 0, -5. Now when I'm using the equation of a straight line y is equal to mx plus c, the first thing I need to do is to calculate the value of my constant, or c. I do that by substituting. This is x, this is y. So I substitute this into the equation. So I have -5 is equal to m, which is 2, multiplied by x, which is 0, plus c. So I have -5 is equal to, this is 0, 2 multiplied by 0 is 0, plus c. So therefore it means that c is equal to -5. From here, it therefore means that the equation of my straight line is equal to y is equal to my m, which is the gradient, is 2, s, my constant is 5, so -5. So this becomes my equation of the straight line. Alright, so let me use the other formula, which is y minus y1 is equal to m into bracket x minus x1. So from here, I have this become my x1 and y1. So I write y minus y1 is -5 is equal to the gradient, which is 2, multiplied by x minus x1, which is 0. So I have here y plus 5 is equal to 2, then multiplied by x, since this is 0. So I have y plus 5 is equal to 2x, and I can rewrite this as y is equal to 2x minus 5. So this becomes my equation of the straight line. Now if you see, you can see that these two equations are the same. So whether you decide to use the values to calculate the constant first and substitute it back into the expression to get the equation of the line, or you use the direct method where you just substitute your value and get your equation, you will get the same answer. Alright, so let's have a look at another example. We have to find the gradient, we have to find the equation of a line with the gradient 3 which passes through the point 2 and -4. So let's write down our solution. Okay, so let me say case 1 or approach 1, and then case 2 for us. You can use any of them. So in this one, I'm going to use y is equal to mx plus c. I know that from this point I have 2, -4. So this is my x, this is my y. My y here is -4 is equal to my gradient m is 3 multiplied by x, which is 2, plus c. So I have -4 is equal to 6 plus c. -4, I bring the 6 to the other side, minus 6 is equal to c, and therefore my c is equal to -10. So I can now substitute that back into the equation. So my equation will now be y is equal to my m, which is the gradient, 3x, and my constant c is -10, so it becomes -10. So this becomes my equation of the straight line. In the second case, we have y minus y1 is equal to m into bracket x minus x1. So my y1 in this case is -4, so I have -4 is equal to my gradient, which is 3s minus x1, which is 2 over here, so I have 2. So this is y plus 4 is equal to 3 multiplied by s will give me 3s, 3 multiplied by -2 will give me -6. So I have y is equal to 3s minus 6. Then I send a +4 to the other side of the equal to sign, it becomes -4. So -4 here. So I have y is equal to 3s minus 6 minus 4 will give me -10. So this become my equation of the straight line, and as usual they are the same over here. Alright, so let's go ahead and try one final example. You can go ahead, pause this video, try your hands on this problem to see if you can get the equation of a straight line. Alright, so let's go ahead and look at the solution to this problem. So we have to find the equation of a straight line with the gradient 2 which means our gradient is 2 through the point 4 and 3. Alright, so for this case, I'm just going to straight ahead use the second method. So y minus y1 is equal to m into bracket x minus x1. So from here, all I need to do is to substitute my values. So I have y minus, my y1 is 3 into bracket m, which is 2 into bracket x minus my x1 is 4. So over here, I have y minus 3 is equal to, I expand this bracket, I have 2x minus 8. From here, I maintain my y here is equal to 2x minus 8. Then I send the negative 3 to the other side, it becomes plus 3. So my y is equal to 2x minus 8 plus 3 will give me minus 5. So this is minus 5. And this becomes my equation of that particular straight line. So thank you so much for watching, and I will see you in the next video where we'll be talking about how to find the equation of a straight line when you are given 2 points on that particular line. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the equation of a straight line given 2 points. Alright, so let's look at the diagram we have over here. So we have a straight line having the first point having the coordinate x1, y1, and then the second point B with the coordinate s2, y2. Now, if we are asked to find the equation of this straight line, we can use the equation or the expression y minus y1 equals m into bracket x minus x1 to get the equation of this straight line in the form y is equal to ms plus a constant c. Now, if you look at this expression, you realize that we have y1, x1, which we can obtain from the first point with the coordinate x1, y1. But we do not know the m, which is the gradient or the slope of this line. So the first thing we do when we have a straight line having 2 points, to find its equation, the first thing we need to find is to calculate the gradient of the line, which can be found by subtracting y2 minus y1 on s2 minus x1. So if you use this in calculating the gradient, the value you obtain over here, you substitute that value into the expression y minus y1 equals, then you have that value over here, which is the gradient, s minus x1. Already you have your x1 and y1 here, so you substitute them over here respectively, and then you find your equation of that particular straight line. Alright, so let's go ahead and have a look at an example to understand and appreciate what we are talking about. So we have to find the equation of a line joining 2 points, 2, 4, 1, 4. One point is 2, 4, and another point is 5, 3. So let's write down our solution. So I will say let A be the first point, which is 2, 4, and B be the second point, which is 5 and 3. Alright, so like I said, the first thing we need to do is to calculate the gradient of this particular 2 points before we use them in finding the equation of the line joining these 2 points A and B. Alright, so to do that, I'll first of all label my coordinates. So this is my x1, my y1, this is my s2, my y2. My gradient now is equal to y2 minus y1 on s2 minus x1. So this is equal to my y2 is 3 minus y1, which is 4, on my s2, which is 5, minus my x1, which is 2. So over here, my gradient is equal to 3 minus 4 will give me a negative 1, and 5 minus 2 will give me 3. So my gradient is negative 1 on 3. Alright, so substituting the gradient m into the equation y minus y1 equals m into bracket x minus x1, I can now go ahead and find the equation of my line joining these 2 points. So I have here y minus my y1 is 4 over here, So I use that. Is equal to my gradient negative 1 on 3 into bracket x minus my x1 over here is positive 2. Alright, so all I need to do is to simplify this expression to get my equation of the straight line. So I have a fraction here, I need to get rid of it. So I use 3 to multiply each term over here. So I have 3 multiplied by y minus 4 is equal to 3 multiplied by negative 1 on 3, then x minus 2. So if I expand this, I have 3y minus 12 is equal to, this will cancel this, so I'm left with negative 1 into bracket s minus 2. Alright, so from here I have 3y minus 12 is equal to negative 1 multiplied by s will give me negative x. Negative 1 multiplied by negative 2 will give me a positive 2. So I can rewrite my equation as 3y is equal to negative x plus 2 plus 12. So I have 3y is equal to negative s plus 14. And this becomes my equation of a straight line. Now, if you like, you can rearrange this. Okay, you can rearrange this and have 3y is equal to 14 minus x. Or if you like, you can bring everything to this side, which will become 3y minus 14 plus x is equal to 0. You can rearrange it how you want, but they all mean the same thing, and they are all the equation of the straight line having the 2 points, this and this. Alright, so let's have a look at another example. We have to find the equation of the line AB in each of the following cases. In case 1, we have the point A with the coordinates 2, negative 1, and the point B with the coordinates 3 and 0. In the second case, we have A with the coordinates 3, 5, and B with the coordinates 5, negative 1. Alright, so let's go ahead and look at the solution for this problem. So for the first example, we have A 2, negative 1 as its coordinates, B having 3 and 0. This is my x1, my y1, my s2, my y2. So I first of all need to find the gradient, which is y2 minus y1 on s2 minus x1. This is equal to, my y2 is 0 minus my y1, which is negative 1, on my s2 is 3 minus my x1, which is 2. So I have over here negative minus 1 will give me positive 1, then 3 minus 2 will also give me 1, and this is equal to 1. So therefore I write down my expression y minus y1 is equal to m into bracket x minus x1 in order to find the equation of my line AB. I do the necessary substitution, that is y minus y1, which is negative 1, is equal to 1 as the gradient, and x minus s1 is 2 over here. So I have here y plus 1 is equal to s minus 2, and this therefore, I'll continue here. So I have y is equal to s minus 2. I maintain this, then I bring the positive 1 to the other side, it becomes negative 1. So my equation of the straight line will now be equal to y is equal to s minus 3. So this becomes my equation of the straight line having the coordinates a and having the point A and B with the coordinates respectively. Alright, so let's look at the second aspect. So I have A with the coordinates 3 and 5, B with the coordinates 5, negative 1. Alright, so I label this x1, y1, s2, y2. As usual, because I'll be using this formula in finding the equation of the straight line, I need to calculate the gradient first. To do that, I have m, which is my gradient or slope, is equal to y2 minus y1 on s2 minus x1. This is equal to, my y2 is negative 1 minus my y1 is 5 on my s2 is 5 minus my x1 is 3. So I have negative 6 here on 2, and this will give me a gradient of negative 3. Now substituting this into the expression, y minus y1 equals m into bracket x minus x1, I have y minus y1, which is 5, to be equal to negative 3 as the gradient, s minus x1, which is 3. So I simplify this expression to have my equation of the straight line. So I have y minus 5 is equal to minus 3s plus 9. Now I have y is equal to minus 3s plus 9. Then I send the negative 5 to the other side, it becomes plus 5. So I have y is equal to minus 3s plus 14 as my equation of the straight line. Alright, so thank you so much for watching. This is how we calculate the equation of a straight line when we are given 2 points on that particular line. So I'll see you in the next video where we'll be talking about the equation of the perpendicular bisector of a line. Thank you once again for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the equation of a perpendicular bisector of a line. Alright, so let's consider this diagram that we have. We have a straight line which is in gold or yellow over here with the point A and B. They all have their respective coordinates. So point A has the coordinate x1 and y1. Point B has the coordinates x2 and y2. Now, if we are to find the line that is perpendicularly bisecting this line, which is the one in green over here, which is the perpendicular bisector, that means the line that is cutting line AB exactly at the middle, forming an angle of 90 degrees. If we are to calculate the equation of that line, let's look at how we do that. Now, to find the equation of any line, we use the formula y minus y1 equals m into bracket x minus x1. This means that we need to know at least a point on that line, and also we need the gradient of the line, the gradient or the slope of the line. But now if we look at the diagram over here, all the information that we have is the point A and B with their coordinates. So how do we use only these 2 points to find the equation of a line that is perpendicular to the point AB? Now, in order for us to do this, we need to at least find a point on the green line over here, as we can see over here. The only way we can do that, since the distance between the middle where the green line cuts the yellow line over here is C, and then we can see these 2 lines over there, it means the distance is the same, which means that the perpendicular bisector is dividing the line exactly at the middle. So if we find the midpoint between A and B, that will give us a point in the middle here, which is also a point on the green line over here. So the first thing we do is to find the midpoint of the line AB. So to find the midpoint, we know midpoint is equal to x1 plus x2 on 2, comma y1 plus y2 on 2. So this will give us our midpoint. Now, after calculating the midpoint, the next thing we need to do is to find the gradient of the line AB. Now, if we find the gradient of that line AB, that becomes M1 as our gradient. We know that the line AB and the green line over here are perpendicular to each other. Because they are perpendicular, if we multiply the gradient of the line AB, which we are saying is M1, and the gradient of the green line, which I'm representing with M2, if I multiply those 2 gradients, I should get -1. Using this expression, after calculating my gradient M1 for the line AB, I can substitute that into this information and get the gradient M2 for the green line. Now, after getting the gradient M2 with the midpoint of the line AB, which is also a point on the green line over here, I can now substitute these 2 informations into this expression to get my equation of the perpendicular bisector of the line AB. Now let's have a look at an example so that you understand and appreciate how to use all this that I've talked about. So we are to find the equation of the perpendicular bisector of the line joining the points P, negative 4, 5 to Q, 2 and 3. Alright, so let's go ahead and write down our solution. Now, for the purpose of this tutorial, I will be drawing our axis so that we can actually appreciate what is going on over here. Right, so let me draw my axis. I have over here my horizontal axis and then my vertical axis, which will be somewhere here. Alright, so let me label my axis. I have here 1, 2, 3, 4. These are not drawn to scale. This is my x axis, this is my y axis. So I have over here, I have negative 1, negative 2, negative 3. If I extend this a little, negative 4. I have over here 1, 2, 3, 4, 5, 6. Over here negative 1, negative 2, negative 3, etc. Alright, so I have the points P with coordinate negative 4, 5 and Q positive 2 and 3. So let me go ahead and plot that on my graph. So my P, the point P is negative 4, that is the X, so negative 4, and then the Y is positive 5, so it's going to meet somewhere around here. This will be my first point, and then my second point is 2, 3. So my X coordinate is 2 and then my Y coordinate is 3, so that is going to meet somewhere here. So I can now go ahead and join these 2 points. Okay, right, so don't mind my imperfect line. So this is my point negative 4, 5, and then my second point Q, which is 2 and 3. Alright, so if this is our line, then it means our perpendicular bisector will be somewhere over here. So let me just draw some line to represent our perpendicular bisector. So let's say something like this, forming an angle of 90 degrees over here. So this, let's say this is our perpendicular bisector of the points P and Q. Alright, now in order to calculate the equation of this perpendicular bisector, we use y minus y1 equals m into bracket x minus x1. Now, like I said, the first thing we need to do is to find the midpoint over here where this golden line or perpendicular bisector divides this line PQ into 2 equal halves. So that is the first thing we need to find. To find that, we use the midpoint formula, which is equal to s1 plus s2 on 2, comma y1 plus y2 on 2. So our midpoint is equal to, our x1 is negative 4 plus our s2 is positive 2 on 2, then our y1 is 5 plus our y2, which is 3 over here, on 2. So this will be equal to, I have over here negative 4 plus 2 will give me negative 2 on 2, comma 3 plus 5 will give me 8. This is also on 2. So my midpoint value is now equal to negative 1 and 4. So the midpoint, or which is the point over here, is the midpoint over here is negative 1 and 4. Alright, so now that we have the midpoint, let's go ahead and calculate the gradient of the line PQ and use that to find the gradient of the perpendicular bisector. So the gradient M of the line PQ, let me use a different color for that. So the gradient of the line PQ will be equal to y2 minus y1 on s2 minus x1, and that will be equal to, this become my x1 y1, this is my s2 y2. So my y2 is 3 minus my y1, which is 5, on my s2, which is 2, minus my s1, which is negative 4. So this will be equal to 3 minus 5 will give me negative 2. 2 minus 4 will give me a positive 6. So this is equal to negative 1 on 3. Right, now we know that if we multiply the gradient m of the line that is in green with the gradient of the perpendicular bisector, which is in gold over here, that should be equal to negative 1. So it means that my green gradient, which is the line PQ, negative 1 on 3 multiplied by m is equal to negative 1. So m is therefore equal to negative 1 on 3, and this is equal to, if you reciprocate this and multiply it, you'll get 3 as the gradient of the line which is perpendicularly bisecting P and Q. So our gradient of the perpendicular bisector is 3 over here. Now from here we can go ahead and find our equation of the perpendicular bisector, now that we have the point 1, 4 and then the gradient 3. So let's go ahead and do that. So our gradient of the line will be equal to y minus y1 equals m into bracket x minus x1. Now our points that we saw in the previous over here, so we have minus 1 and 4, minus 1, 4, and then our gradient m, we saw that was 3. So let's do the substitution. We have y minus our y1 is 4 over here equals the gradient 3 into bracket x minus negative 1 for our s over here. So I have y minus 4 equals 3 into bracket s plus 1. Y minus 4 is equal to 3 multiplied by s will give me 3s, plus 3 multiplied by 1 will give me 3. So y minus 4 minus 3s minus 3 is equal to 0. And then I have over here y minus 3s minus 4 minus 3 will give me minus 7 is equal to 0. So this becomes my equation of the perpendicular bisector, or I can rewrite this as y is equal to, I send negative 3s and negative 7 to the other side, it becomes 3s plus 7. So the equation here in gold becomes the equation of my perpendicular bisector, as we can see in this drawing that I have over here. Alright, so let's go ahead and have a look at another example. So we have to find the equation of the perpendicular bisector of the line joining the point A 2, 4 and then B 5, 3. Alright, so let's go ahead and write down our solution. So I'll try and draw the graph so that we can actually visualize what we are talking about. So I have over here 1, 2, 3, 4, 5, 6. This is my x-axis. This is my y-axis. So this is 1, 2, 3, 4, and let's see 5 over here. Alright, so my first point here is 2, 4, so it means my s is 2, then my y is 4, so it's somewhere here. And then my second point, so this is A 2, 4. My second point is B 5, 3, so I have 5 and 3, that is going to meet somewhere here. So this is B, which is 5 and 3. Alright, so I can now join these two lines, these 2 points, to have my straight line. Now this is a straight line, so because I'm using freehand sketch, it's not straight, but if you plot it in a graph you should get a straight line. Alright, so let me draw my perpendicular bisector. So that will be a line that is cutting through this point at an angle of 90, and then this distance over here from A to the midpoint and then from the midpoint to B are equal. Alright, so now that we have this, the first thing we need to do is to find a midpoint over here. So our midpoint MD is equal to S1 plus S2 on 2, Y1 plus Y2 on 2. So that will be equal to my S1 is 2 here, plus my S2 is 5 on 2, then my Y1 is 4, plus my Y2 which is 3 on 2. So my midpoint is equal to 7 on 2, and then over here 7 on 2 as well. So that becomes my midpoint for these 2 points A and B. Now that I have the midpoint, I need to calculate the gradient of the line AB and use that to find the gradient of the perpendicular bisector. So to do that, my gradient of the line AB, M, is equal to y2 minus y1 on s2 minus x1, and that is equal to my y2 is 3 over here minus my y1 is 4 on s2 is 5 minus x1 is 2. So this is equal to 3 minus 4 will give me negative 1 on 5 minus 2 will give me 3. So 1 over 3, negative 1 over 3 becomes my gradient of the line AB. So to find the line of the perpendicular bisector, because they are perpendicular, it means M multiplied by the other M, which is the gradient of the perpendicular bisector, which is in gold over here, should be equal to negative 1. So the M over here will be equal to negative 1 on the white M, which is negative 1 on 3. So this is equal to negative 1. We remove the revision sign, it becomes multiplication, and then we reciprocate this, we get negative 3 on 1. So negative 1 multiplied by negative 3 will give us positive 3. So the gradient of our line perpendicular to the point A and B is 3. So now that we have the point 7 on 2, 7 on 2, and the gradient 3, let's go ahead and find the equation of the perpendicular bisector. So our points are 7 on 2, 7 on 2, and then our gradient M is equal to 3. Let's say our point is C. So the equation becomes y minus y1 equals M into bracket x minus x1. So I have here y minus y1 is 7 on 2 is equal to M, which is 3 into bracket s minus 7 on 2. Alright, so from here I multiply through by 2, so I have 2 multiplied by y minus 7 on 2 is equal to 2 multiplied by 3 into bracket s minus 7 on 2. So from there I have 2y minus, this will cancel this, so I have 7 here is equal to, this becomes 6 multiplied by s minus 7 on 2. So from here I proceed, I have 2y minus 7 is equal to 6 multiplied by x will give me 6x minus 6 multiplied by 7 on 2. 2 will go into itself 1, it will go here 3 times. 3 multiplied by 7 will give us 21. So from here I can now go ahead and simplify my equation. So that will give me 2y minus 7, sorry, so I have 2y here is equal to 6s minus 21. Then I send the negative 7 to the other side, it becomes positive 7. So I have 2y is equal to 6s minus 21 plus 7 will give me minus 14. So I have this as my equation, or if I like I can divide both sides by 2. So I have y is equal to 3s minus 14 on 2 is 7. So this becomes my equation of the perpendicular bisector of the line cutting through the point A and B as shown over here. So thank you so much for watching. This is how we find the equation of the perpendicular bisector of any given line. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, I want to look at how to draw a straight line when given its equation. Now let's begin. Now there are several standard forms of writing the equation of a straight line, so we'll be looking at those forms one by one. Now if we look at the first example or the first diagram we have over here, we can see the Cartesian plane, the x and then the y axis, and then we can see a straight line here. This line is of the form x is equal to a. So whenever we have an equation given to us and it's of the form just x is equal to a number, this is how the graph looks like. This means that we don't have the y component of the coordinate, and so we only have the x component, so which means the y component is 0. So we have x and 0, so the point is over here, and then that becomes a straight line vertically upwards and is always parallel to the y axis. Right, now when we have the second example over here, this sort of graph where we have the line being horizontal and parallel to the x-axis is of the form y is equal to, let's say, a number b. So whenever we just have the y coordinate, it means the x coordinate is 0, and therefore since x is 0 and y is 2, the point is located somewhere on the y axis, and then it becomes a horizontal straight line which is parallel to the x axis, as you can see over here. Now the next form in which the equation of a line can appear is of the form y is equal to mx. This form means that the equation or the line that you are about to draw has a gradient, or it is slightly tilted. So it's not going to be a vertical line, it's not going to be a horizontal line, but it will be slightly tilted. Now because it does not have plus c attached to it, this form of straight line always passes through the origin. They always pass through the origin. So let's say we have y is equal to 4x. This graph or this line will always pass through the origin. That is how these sort of graphs behave. So they always pass through the origin and they have a gradient. So we can just extend these lines over here to get a horizontal and vertical component, and we can use those values to calculate the gradient for both lines. Now the last form in which it can take is this form where we normally say y is equal to ms plus c. Now in this form we can see that there is a constant attached to the mx, which is c. So that means that this line now does not pass through the origin, but it cuts the y-axis at a particular number, and that number becomes our constant, or c. So if you look at this graph over here, the one at the top is cutting the y-axis at 1, as you can see over here. So it means our constant is 1. Over here you can see that there's -1 here, so which means the gradient here is 1. So we have -1 here, so therefore this line is cutting the y-axis at -1, and therefore the -1 becomes our constant. So for this sort of graph, y is equal to ms plus c, they don't pass through the origin, they are not vertical or horizontal, they are slanted. You can find their gradient, and they always cut through the y-axis at a particular point. Now let's have a look at an example of a given equation and how we can use those equations to draw a straight line on the Cartesian plane. Alright, so we are to sketch the lines x is equal to 5, y is equal to 10, and y is equal to x on the same axis. We are to describe the triangle formed by these lines. Okay, so this is a very good example. Let's go ahead and look at that. All right, so we have here our solution. So we have the line s is equal to 5, y is equal to 10. Sorry, this is supposed to be 0 is 0 here, y is equal to 0, so it's 0 here, and then the last one is y is equal to x. All right, so since we have these guys direct, we can go ahead and label our Cartesian plane. So we have our y-axis, we have our x-axis. So let me label it. So this is 1, 2, 3, 4, 5, 6, and 7. This is 1, 2, 3, 4, 5, and 6. All right, so the first one we have is x is equal to 5. As we've seen in the previous illustration, whenever we have just the value x is equal to a number, it means it is going to be vertical and it will be parallel to the y-axis. So we have here x is equal to 5. So okay, so this is our line. Now we have the second line is y is equal to 0. So we have our y to be 0. Because y is 0, is going to lie on the horizontal axis, which is our x-axis. Because in the previous example, we saw that whenever y is equal to a number, it is always horizontal and parallel to the x-axis. This time around, it is not 1 for us to draw it at the top here. It is 0, so it will be on the axis over here. Oh, now that is a terrible line. Alright, so let me just use freehand sketch. So it is going to be on this axis over here. Okay, now the last one is y is equal to x. So y is equal to x means when x is 1, y is 1, when x is 2, y is 2. We realize that it will be at the middle over here. So it will be a straight line moving upward from the origin. So let's draw that. So we have something like this. Okay, so this is our line x is equal to 5. This is our line y is equal to 0, and this is our line y is equal to s over here. Alright, so this is the triangle that we have. We can see that from the triangle, this is a right angled triangle. Since this is a straight horizontal line, this is a straight vertical line, and this is a diagonal line cutting the both of them. So this would be a right angle triangle. So the triangle formed over here will be an isosceles right angle triangle. So we have isosceles right angled triangle. All right, so let's proceed. Now we have the second example. We have to draw y is equal to x minus 1 and 3x plus 4y is equal to 24 on the same axis. Right, so let's proceed to go and look at the solution for this problem. So we have the equation y is equal to x minus 1, and then we have another equation 3x plus 4y equals 24. Now in order for us to plot these equations, we need to get the coordinate or the points for this particular graph. Now what we need to do is, first of all, we say let y be equal to 0. If y is 0, then it means that we substitute y here. We have 0 is equal to x minus 1, which therefore means that if I bring the negative 1 here, I have 1 is equal to x. So therefore it means when y is equal to 0, we have the point 1, 0, where 1 is the x value that we found over here. Sorry, when 1 is the x value that we found over here and y is the 0 that we said it should be. The second thing we said we do is to say let x be equal to 0. Now when x is 0, we have y is equal to 0 minus 1, and therefore y is equal to negative 1. So when s is equal to 0, we have 0 minus 1 as our point for us to plot. Alright, let's look at the second scenario. So we do the same thing. We say let y be 0, and if y is 0, we have 3x over here to be equal to 24, and our x is 24 on 3. So which means our value of x over here, 24 on 3 will give us 8. Will give us 8 over here. So when y is equal to 0, we have the point x, which is 8, and then y, which is 0. The second one, we say let x be equal to 0. Now if x is 0, this becomes 0. So we have 4y is equal to 24. We divide both sides by 4. Then we have our y to be equal to 24 on 4. That will give us 6. So the point we have over here will become our x, which is 0, and then our y, which is 6. Now that we have these 4 points, we can go ahead and plot them on the Cartesian plane. So I have my y-axis, my x-axis. This is my origin. So I can go ahead and label my axis. I have 1 here, 2, 3, 4, 5, 6, 7. I have here -1, -2, -3. I have here 1, 2, 3, 4, 5, and 6. Okay, so this is 8, and okay, so the next thing I do is to plot them equation by equation. So the first equation, I have x to be 1, y is equal to 0. So x is 1, y is equal to 0. So the first point is x, which is over here. Y is 0, so they will meet at this side. So I write the point. Whenever you plot a point, always make sure you write the point. So this will be my first point, 1, 0. Okay, now the second point is 0, -1. So my x is 0, which is over here, and my y is -1, so it will meet over here. So that becomes 0, -1. Okay, so now this becomes my 2 points, and then I can now join them in a straight line to have my straight line graph. So it's going to look something like this. Okay, so now that I'm done plotting these 2 points and drawing the line, I need to write the equation on the line. So I have y is equal to s minus 1. Alright, so let me plot the second points for this equation. I have 8, 0. So x is 8, y is 0. So it will meet on the point 8 over here. So I can write that over there. So I have 8, 0. Then I have the second one, 0, 6. So x is 0, y is 6. So it is over here. So I have here 0, 6. Alright, so I can now also join these 2 points over here in a straight line. Okay, so after joining them, I can now write the equation on it. So I have 3x plus 4y is equal to 24. And this is how our graph is going to look like when you plot these 2 equations on your Cartesian plane. Now note that I'm using a freehand sketch, and so my lines are not straight. You need to use a ruler on your graph to have your lines very straight. Alright, let's look at one final example. So in this example, we have to sketch the following on the same axis. We have the first equation to be x plus 3y minus 6 is equal to 0. So we have x plus 3y minus 6 equals 0. Then we have the second equation, y is equal to 2 minus x. Alright, so let's look at what we do first. So we say let x be 0. And when x is 0, we have this equation become 0 plus 3y minus 6 equals 0. So we have 3y is equal to, I send the -6 to the other side, becomes +6. So therefore y equals 2 if I divide both sides by 3. So it means my point over here becomes x will be 0, my y will be 2. Now, and I'll say let y now be 0. If y is 0, I have x plus 3 into bracket 0 minus 6 equals 0. So x plus 0 minus 6 equals 0. So x is therefore equal to, I send the -6 to the other side, becomes +6. So therefore my point over here is 6 and 0. Alright, so let me tackle this second equation now. I say let x be equal to 0, and if that is the case, y will be equal to 2 minus 0, so y is equal to 2. So I have here 0, 2 as my point. The 0 is the x, the 2 is the y value over here. From there I say let y be 0 now, so I have here 0 is equal to 2 minus x. So I bring the negative s to this side of the equation, it becomes s is equal to 2. So I have the second point to be 2, 0. Alright, so from there I can go ahead and plot my graph. So I label my axes. So I have here 1, 2, 3, 4, 5. This is 1, 2, 3, 4, let me see, 5. Okay, this is 6 over here. So for this guy I'm going to use red, and this guy, this equation, I'm going to use blue. Alright, so let's plot the red one. So for the red we have x is 0, y is 2. So x is 0, y is positive 2. That will be at the top over here. So I label that 0, 2. And then for the second point I have 6, 0. So x is 6, which is over here. Y is 0, so it will also be on the same axis. So I have over here 6, 0. So this become my two lines, and then I can now draw a straight line connecting the two of them. So something like this. Okay, so now that I have this, I can now write my equation on them. So this will be x plus 3y minus 6 is equal to 0. Okay, now let's plot the second line. That will be blue. So for the second line we have 0, which is x, and 2 for y. So 0, which is x, and 2, that will also be over here. So we have the second point also over here. So I'll do that 0, 2, and then I have 2, 0. So my x is 2, my y is 0. So that will be over here. So I have over here 2, 0. Okay, so my second line is from here coming down like this. Alright, so I can now write my equation here. Y is equal to 2 minus x, and this becomes my equation on this particular straight line. So this is how we draw straight lines or line on a graph when you are given their equation. The first thing you need to do is to analyze which form of the equation is the equation given to you is, whether it's just s is equal to a number, let's say s is equal to a, or y is equal to b, or let's say y is equal to mx, or y is equal to mx plus c, so that you know the form in which the graph will take. And from there, if you have an equation, you make x the subject, then you get your value of y. You make x 0, you get the value of y. You make y 0, you get the value of x, and then you plot those 2 points together to have your straight line on the graph. So thank you so much for watching, and I'll see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to find the point of intersection of two lines when you are given their equations. So without further ado, let's begin. Now, in order for us to find the point of intersection of any two lines given their equation, all we need to do is to solve the equations simultaneously and find the value of the x and the y coordinate, and that will give us the point of intersection of these two lines. So let's begin by looking at an example that we have over here. So we have to sketch the line x plus 2y is equal to 1 and 2x plus 3y is equal to 4 on the same axis, and find the coordinate of the point where they intersect. Alright, so let's go ahead and write down our solution. Now, in order for us to sketch this line, the first one we have is x plus 2y is equal to 1, and then the other equation is 2x plus 3y is equal to 4. So the first thing we do is we say over here, let x be equal to 0. Now if x is equal to 0, it means we have 2y is equal to 1, and therefore y is equal to half. So it means from here we have the point x0, y to be half as one of the points for this equation. Now the next thing we do is we say let y be equal to 0. Now if y is equal to 0, then the equation over here becomes x plus 2 into bracket 0 is equal to 1. Just like over here we have 2y, so it's supposed to be 0 plus 2y. So over here we have x is equal to 1. So therefore our coordinate over here will be the value of x, which is 1, and then the 0 over here. So these are the 2 points we are going to plot for this equation. And then for this equation we have over here, we do the same thing. We say let x be equal to 0, and that will give us 2 multiplied by 0 plus 3y is equal to 4. Therefore 3y equals 4. Y will give us 4 on 3. So our coordinate over here is x is 0, y is 4 on 3. Then we say let y now be equal to 0. Now if y is equal to 0, we have 2x plus 3 into bracket 0 is equal to 4. So 2x equals 4 over here. Then our x will be equal to 2. So it means we have the second coordinate to be x is 2, y is 0. Right, so let me use a different one. So we are going to plot these coordinates to get our lines for these particular two equations. So let's say I draw the Cartesian plane. So just a rough sketch of my Cartesian plane, and then I have here is 0, 1, 2, 3, 4, 5, 6. This is the x-axis, this is the y-axis. Then I have from here 1, 2, 3, 4. I have -1 here, -2, -3, and so on. So the first point I have is 0.5. So my x coordinate is 0, then the y coordinate is half, so it's going to be at the top over here. Then let me use a different color for the line. Okay, so let me use green. So it's over here, so it is 0.5. Then the second one is 1 and 0, so my x is 1 and then my 0 is y, so it is over here, so it is 1 and 0. So our line will pass something like this, pass through over here. So this is the first line, this is x plus 2y is equal to 1. Now let's plot the second line. We have 0 and 4 on 3. So 0 and 4 on 3. 0 is the x, so it's over here. 4 on 3, that will give us 1 point something. So it will be somewhere, let's say somewhere here, 1 point something is over here. So we have over here 0, 4 on 3. And then the second one we have is 2, 0. So this is 2, and then 0, it is also over here. So this is 2, 0. So if we draw this line also to pass over here, pass here, you see that it will go and go and go and cut the first line at a point somewhere over here. Now because this is a rough sketch, I can use the graph to estimate the x and then the y axis of this point over here. So this is the point x and y that we want to find. Now if you draw this thing to scale on a graph, you should be able to find the answer by tracing from the graph. But since this is not up to scale, let's go ahead and solve the two equations that we have simultaneously and find the point over here where they met. So let's look at that. So the equation we had was, we have x plus 2y is equal to 1 as our first equation, and then we have our second equation to be 2x plus 3y is equal to 4 as equation 2. Now from equation 1, let me make x the subject. So making x the subject in equation 1. If I do that, I have x is equal to 1 minus 2y. That is, I maintain the x here and then I send the 2y to the other side of the equal to sign. So let me make this equation 3. So now I substitute equation 3 into equation 2. If I do that, I have 2 into bracket. The x will now be 1 minus 2y plus the 3y over here is equal to 4. So I have 2 multiplied by 1 will give me 2. 2 multiplied by 2 will give me 4y plus 3y equals 4. So I have my 2 here. Negative 4y plus 3y will give me negative y, and this is equal to 4. So I send the y to the other side of the equal to sign. So I have my 2 here. I bring the 4 to the other side, it becomes minus 4 is equal to the y to the other side becomes positive, so y. So 2 minus 4 will give me negative 2 is equal to y, and therefore y is equal to negative 2. Now that I have my value for y, all I need to do is substitute y into any of the equations, either equation 1, 2, or even equation 3. So I'll do that into equation 3, and then I'll have x is equal to 1 minus 2 into bracket the y now, which is negative 2 over here. So my x will be equal to 1. Negative 2 multiplied by negative 2 will give me positive 4, so it becomes 4, and therefore x is equal to 5. So therefore it means that the point over here where these two lines met over here is x is equal to 5, and then y is equal to negative 2. So this is the point of intersection of the two lines that were given in this particular question. Alright, so let's go ahead and look at another example. We are to find the coordinate of the vertices of the triangle whose side have the equation x plus y is equal to 4, 2x minus y is equal to 8, and x plus 2y is equal to negative 1. So let's go ahead and look at how to solve this problem. So let's write down our solution. Now, the first equation we have is x plus y is equal to 4. Then the next equation we have is 2x minus y is equal to 8. And then we have another equation that is x plus 2y is equal to negative 1. Now let's go ahead and try to find the coordinate so we can sketch this graph. So x plus y is equal to 4. If we say let x be equal to 0, we are going to have y to be equal to 4. If we let y to be 0, x will be equal to 4. So it means for this one, the coordinate or the point we have over here will be x is 0, y is 4, or for if we say let y is equal to 0, we will have x to be 4, y to be 0. So these are the points we are going to plot. Now for the second equation, that is 2x minus y is equal to 8, we do the same thing. Let x be equal to 0. If we do that, we are going to have 2 into bracket 0 minus y is equal to 8. Therefore we have minus y is equal to 8, and therefore y equals negative 8. This therefore means that the first point we have over here will be x, which is 0, and then y, which is negative 8. And the second point we say let y be equal to 0. If that is the case, we have 2x minus 0 is equal to 8. Therefore we have 2x is equal to 8, and therefore x will be equal to 4. And so the second point over here will be 4, which is the value of x, and then y, which is 0 over here. So this is the second point we are going to plot for this particular graph. And then for the third point, coming over here, we say, as usual, let x be equal to 0. If we do that, we are going to have 2y is equal to negative 1, and therefore our y will be equal to negative 1 on 2. So the first point we have over here will be 0, negative 1 on 2. Then we say let y be equal to 0. if y is equal to 0, everything here will be 0. Therefore, x will be equal to -1. So the second point will be -1 and 0. Okay, so this is how we get the point. Now, if I go ahead and draw my Cartesian plane, okay, and I sketch all of these lines. So this is my y-axis, this is my x-axis. Now, because of space, I would like to just do a rough sketch. If I sketch this point, the point that I have over here, I will have something that looks like this. Another line coming from the top to the bottom somewhere here, and then another line passing to cut the line over here, okay, meeting at a point over here, -8 over here. Then here will be a point 4, sorry, the eraser, okay. So here will pass through, a line will pass over here through this line, then cut the y-axis over here. So it will cut over here at -8, and then over here will be 4, and then this is our 0, and then yeah, the other labels will come. So the graph is going to look something like this. Now, it means that we have this place as our vertex A, or vertices A, this point as vertices B, and this point as vertices C, and these are the points that we are supposed to solve this equation simultaneously to find the point where they intersect. Now, if you look to the points that we have, you see that we have a point here 4, 0 when we solve the first equation, and then we have another point here 4, 0, which is also what we got when we solve this particular equation. This means that 2 of the lines pass through the same point. So that will be one of the vertices, and that place is over here. That is where I'm denoting as A. So one of the first vertices is 4, 0, and we already obtained that by solving the equation x plus y is equal to 4 and 2x minus y is equal to 8. Now all that is left is for us to find the vertex B and vertex C. We can find vertex B by solving the equation of the line over here, this and this, and then we can find vertex C by solving the equation of the line over here and the one over here. So by the way, this one, the line over here this is the 2x minus y is equal to 8. The one over here is the x plus y is equal to 4, and then the last one over here is the x plus 2y is equal to -1. So if you want to find the vertex B over here, we solve the equation 2x minus y is equal to 8 and x plus 2y is equal to -1. If you want to find C, we solve that of x plus 2y is equal to -1 and x plus y is equal to 4. All right, so let's go ahead and solve them and look at the points where they meet. So for vertex B, okay, so we have to solve the equation x plus 2y is equal to -1. This is our equation 1, and our equation 2 will be 2x minus y is equal to 8 as our equation 2. All right, now if you look at what we have over here, we can go ahead and solve this particular equation simultaneously and find our answer. So the first thing I'll do is I will make S the subject in equation 1. So that will give me x is equal to -1 minus 2y. So if I substitute, let me make this equation 3. Substitute equation 3 into equation 2, I will get 2 into bracket -1 minus 2y minus y is equal to 8. If I multiply 2, I get -2 minus 4y minus y equals 8. So I have negative 2 minus 5y equals 8. Therefore, I have minus 5y is equal to 8 plus 2. This gives me minus 5y equals 10, and therefore gives me, if I solve this and I find y, my y will be equal to negative 2. Now if I substitute y back into equation 3 to get my x value, I'm going to get s is equal to minus 1 minus 2 into bracket minus 2. This will give me minus 1. Minus 2 multiplied by minus 2 will give me positive 4, and therefore x will be 3. So therefore, it means that the vertex B, the coordinates are 3 and negative 2. So it means the point over here is 3 and negative 2. Right, so let's go ahead and find vertex C. That is, we are going to solve the equation x plus 2y is equal to negative 1 and x plus y is equal to 4. So right, so let's do that. So let me do this and use a different color for that. So for vertex C or point C, we are going to solve the equation x plus y is equal to 4, our equation 1, and then x plus 2y is equal to negative 1 as our equation 2. Already we have x here, so I can make x the subject over here. If I do that, make x the subject in equation 1, I'll have s is equal to 4 minus y. This will become my equation 3. If I substitute equation 3 into equation 2, I get x will now become 4 minus y plus 2y is equal to minus 1. That is using the equation 2, where I substitute this equation 3 into it. So I now have 4 minus y plus 2y equals minus 1. So this gives me 4 plus y equals minus 1. Y is equal to minus 1. I send the positive 4 to the other side, becomes minus 4. Then y is equal to minus 5 over here. Now, if I substitute minus 5, okay, substituting y equals minus 5 into equation 3, I get x to be equal to 4 minus into bracket minus 5, and then x will be equal to 4. Negative becomes positive, then 5. So s is equal to 9. So for vertex C, the coordinates are 9 for x and then negative 5 for y. So it means the point over here is 9 and negative 5 over here. So this is where they meet. So that is how we solve the intersection of two lines to find where they meet at a particular point. So if we have the line of an equation of a line, so for instance we have line A, line B, line C, and they intersect at a particular point, you just solve the two equations simultaneously and then you find the point where they intersect. Thank you so much for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at some of the Cambridge AS and A-level coordinate geometry likely examination questions. Before we begin, if you're new to my science tutorial, make sure you subscribe to the channel and turn on the notification button so that you do not miss any of our latest tutorials. So without further ado, let's begin. So let's start by looking at some examples. Example number 1. We are to find the vertices of a triangle ABC whose sides are given by the lines AB, x minus 2y is equal to negative 1, BC, 7x plus 6y is equal to 53, and AC, 9x plus 2y is equal to 11. We are to show that the triangle is isosceles. Right, so let's go ahead and write down the solution for this problem. Now, from the diagram we have over here, this diagram shows the lines, the three lines that came together to form the triangle over here. Now, the vertices over here on point A, B, and C. In order for us to find these vertices, we need to solve two equations, or the equations of two lines that came to cross each other to form that particular vertex over there. So for instance, if we want to find vertex A, we need to solve the equation x minus 2y is equal to -1 and 9x plus 2y is equal to 11, as these are the two lines that came together to meet at this point to give us vertex A. So let's go ahead and look at that. So for vertex A, or point A, we need to solve the equation x minus 2y is equal to -1. This is our equation 1. And 9x plus 2y is equal to 11 as our equation 2. Now, if you compare equation 1 and equation 2, we have -2y over here, we have +2y over here. So I'm going to use the elimination method to solve these equations simultaneously. So I'll say add equation 1 and equation 2. So if I do that, I'm going to have x minus 2y is equal to -1 plus 9x plus 2y is equal to 11. So x plus 9x will give me 10x. -2y plus 2y will give me 0. This is equal to -1 plus 11 will give me 10. Now I have 10s is equal to 10. If I divide both sides by 10, s will give me a value of 1. Now that I have my value of x, I'll need to substitute x, which is equal to 1, into any of the equations, either equation 1 or equation 2. So I'll put it into equation 1 for this example. So I have 1 minus 2y is equal to -1. So I maintain my -2y here. That will be equal to -1 here. The +1 over here on the left hand side, I send it to the right hand side, it becomes -1. So I have -2y is equal to -2. I divide both sides by -2 to let my y stand alone, and my y will now give me a value of 1. So it means for the vertex A over here, it has the point or the coordinates x and y, and that is equal to x is 1, y is also 1. So that is the point for the vertex A. Now for the vertex B, we need to solve the equation of the two lines that came to form the vertex B, that is x minus 2y is equal to -1 and 7x plus 6y is equal to 53. So let's go ahead and look at that. So point B, as I mentioned earlier, we will be using the equation x minus 2y is equal to -1. This will be our equation 1, and 7x plus 6y is equal to 53 as our equation 2. Now if I look at equation 1 and equation 2, if I multiply equation 1 by 3, I can get 6y over here, which I can cancel using the elimination method. So I'm going to start by saying multiply equation 1 by 3, and if I do that, that will give me 3x minus 6y is equal to 3. This becomes our equation 3. So I can now say add equation 2 and 3. By adding them, I have equation 2 is 7x plus 6y is equal to 53, and then equation 3 is 3x minus 6y is equal to 3. Now 7x plus 3x, that will give me 10x. 6y minus 6y will give me 0, so that is gone. 53 plus 3, sorry, this is minus 1. This is supposed to be minus 1 over here. So this is minus 3 here. This is minus 3. So 53 minus 3 will give me 50. So I divide both sides by 10. Then my x will give me a value of 5. If I substitute the value of x into any of the equations, let's say equation 1,
into equation 1, I'm going to have x minus 2y is equal to negative 1, which is the equation we have over here. X minus 2y is equal to negative 1. And then my x value is now 5, so I have 5 minus 2y is equal to negative 1. Negative 2y is equal to negative 1. I send the 5 to the right hand side, it becomes negative 5. So negative 2y is equal to negative 6. To find my y, I divide both sides by negative 2. So I have negative 6 on negative 2. And that will give me the y value of 3. So it means the points or the coordinates for my point B is x is equal to 5 and B is equal to 3. So the B over here has the points 5 and 3. Now let's go ahead and find the point or the coordinate for the vertex C. So to find the coordinate for vertex C, we need to solve the equation 9x plus 2y is equal to 11 and 7x plus 6y is equal to 53. So let's go ahead and do that and find the coordinates over there. So for point C, we'll be solving the two equations. 9x plus 2y is equal to 11 as our equation 1, and 7x plus 6y is equal to 53, this as our equation 2. So I see that I have 2y here, 2y over here. I'll say multiply equation 1 by 3. If I do that, I am going to get 27x plus 6y is equal to 33. From here, I can now say subtract equation 2 from equation 3. So I'm going to have 27x, this is my equation 3. So 27x plus 6y is equal to 33 minus 7x plus 6y is equal to 53. So 27x minus 7x will give me 20x. 6y minus 6y will give me 0. 33 minus 53 will give me negative 20. So if I divide both sides by 20, my x value becomes negative 1. If I substitute x value into any of the equations, say equation 1, I'm going to get 9 to bracket negative 1 plus 2y is equal to 11. So this gives me negative 9 plus 2y is equal to 11. I have 2y here is equal to 11. The negative 9 to the other side becomes plus 9. So 2y is equal to 20, and therefore y will be equal to 10. So it means for point C, my coordinates are x is equal to negative 1 and then y is equal to 10. So I have over here negative 1 and 10. So that completes the first aspect of this question, which demands that we find the coordinate of these vertices over here. Now the II aspect says that we should show that the triangle is isosceles. Now for an isosceles triangle, it has two of its lengths being equal, or the distance of two lengths of an isosceles triangle is equal. What it means is that we need to find the distance between, for instance, let's say point AB. We need to find distance AB, find the distance BC over here, and then we should also find the distance AC, and compare. If two of the distances are the same, then it means that our triangle is indeed an isosceles triangle. So let's go ahead and look at that. So let me erase everything here. Okay, so let's begin. So we have our point A has the coordinates 1, 1, B has the coordinates 5, 3, and C has the coordinate negative 1 and 10. And we have to find the distance of AB, then we find the distance BC, and then we also find the distance AC, and compare and see if they are all the same. Now, to find the distance between 2 points, say AB, the formula is the root of x squared minus x1 all squared plus y squared minus y1 all squared. Okay, so for AB, A become x1 y1, and then B becomes x2 y2. So this is equal to our x2 here is 5 minus x1, which is 1 squared, plus our y2 is 3 minus y1, which is 1 all squared. So this will give me, if I compute everything here, I'm going to have 4 squared, which is 16, plus here will give me 2. 2 squared is 4, and then everything here will give me root 20. Now let me find BC. So the formula is still the same, x squared minus x1 all squared plus y2 minus y1 all squared. Now, for this particular case, because we are using B and C, our coordinates will change. So, since B is the first point over here, this becomes x1, y1. Here is x2, y2. So this will be equal to, my x2 is -1 minus my x1 is 5. I square that, plus my y2 is 10 minus my y1, which is 3, all squared. So if I compute everything here into the calculator, -1 minus 5 will give me -6, minus 6 squared will give me 36, plus 10 minus 3 will give me 7, 7 squared will give me 49, and then 36 plus 49 will give me the root of 85. Now, the last one is to find AC. So for AC, the formula is still the same, x2 minus x1 all squared plus y2 minus y1 all squared. Alright. So, since we have A and C, A becomes x1, y1, then this becomes x2, y2. So this is equal to, my x2 is -1 minus my x1 is 1 all squared, plus my y2 is 10 minus my y1, which is 1 all squared. So this will give me the root of -2 squared will give me 4, plus 10 minus 1 will give me 9. 9 squared is 81. So I have the root of 4 plus 81 will give me root 85. Now if you look at it, you realize that the distance BC is equal to the distance AC. Because BC is equal to AC, it means that the triangle that we were given is indeed an isosceles triangle, since the distance between two of the points are the same. Alright, so let's have a look at another example. So example number 2. Two sides of a parallelogram are formed by parts of the lines 2x minus y is equal to -9 and x minus 2y is equal to -9. We are to show these two lines on a graph, and find the coordinate of the vertex where they intersect. Now, for us to be able to draw or show this on a graph, we need to do the following. So solution. The first thing we say is, for the equation 2x minus y is equal to -9, we say let x be 0. And if x is 0, we have -y is equal to -9, and therefore it means that our y is equal to 9. So we have the coordinates 0 and 9. So we now say let y be 0. If y is equal to 0, now we have 2x is equal to -9, and then x will be equal to -9 on 2. So the second coordinate will be -9 on 2, and 0. Then for the second equation, we have x minus 2y is equal to negative 9. We do the same thing. Let x be equal to 0. So we have negative 2y is equal to negative 9. And then that will give us y to be equal to negative 9 on 2 will give me 9 on 2. Now we say let y be equal to 0. If y is equal to 0, then we have x is equal to negative 9. So here our point will be negative 9, 0. And for the first case over here, we are going to have our x is 0, our y is 9 on 2. Alright, so using these points here, this point, and this point, we can now draw this on the graph. So if we draw this, we are going to have a graph looking like this. Where this will be 2x minus y is equal to negative 9, and then here will be x minus 2y equals negative 9. Okay, so this is for this line, and then this is for this line over here. Alright, so the next thing we have to do is to find the coordinates of the vectors where they intersect. So it means where they intersect over here, let me use another color for that. The point where they intersect over here, if you draw this on the graph really well, you can easily trace the x and then the y coordinates to get your answer. But since this is just a rough sketch, we need to solve this equation simultaneously in order for us to get the coordinates. So let's go ahead and do that. So we have 2x minus y is equal to negative 9 as our equation 1, and then x minus 2y is equal to negative 9 as our equation 2. Alright, so we have negative 2 here. I will say multiply, in order to use elimination method, I will say multiply equation 1 by 2. If I do that, I'll have 4x minus 2y is equal to minus 18. This will become my equation 3. Then I can now say subtract equation 2 from 3. So it becomes 3 minus 2. Okay, so I have my equation 3 here, 4x minus 2y equals minus 18, then minus x minus 2y is equal to minus 9. So 4x minus x will give me 3x, minus 2y minus minus 2y will give me minus 2y plus 2y, and that will give me 0. So they cancel each other since we are subtracting. Now minus 18 minus minus 9 will give me minus 18 plus 9, and that will give me minus 9 over here. So I divide both sides by 3. The value of x will become negative 3. So if I substitute s is equal to minus 3 into equation 1, I'm going to have 2 into bracket minus 3 minus y is equal to minus 9. This gives me minus 6 minus y is equal to minus 9. And then minus y is equal to minus 9. The negative 6 goes to the other side of the equal to sign, becomes plus 6. And then minus y will give me minus 3 over here. Divide both sides by negative 1. Then this will cancel this. I have y to be equal to 3 now. So it means that my coordinates, okay, for the point of intersection of those two lines given by these two equations over here becomes my x value is minus 3 and then my y value is 3. So if I go back over here, it means the point over here is minus 3 and positive 3. So it means the x value here is minus 3 and then the y value here is positive 3 over here. Alright, so thank you so much for watching. This is how we solve some of the problems on coordinate geometry, specifically when you have two lines intersecting to create a point and you are asked to find the coordinates of that particular point, all you have to do is to solve the equations of those two lines simultaneously, either by the substitution or the elimination method, to get the two values, the x and then the y value, as the point or the coordinate of that particular point. So thank you once again for watching, and I will see you in the next video. Bye bye.